Hello everyone, and welcome to this course on React-Redux. In this course, we'll be going over the complete guide to React. Not only that, we'll see how React works under the hood as well. This will also be a complete guide to Redux. And of course, we'll be going over how to make Redux work with React. We'll also cover the complete guide to routing in React as well. And we'll also go deep and look at how React Router works under the hood. We will also cover modern Google and Facebook OAuth logins. And finally, we'll learn how to set up authentication in React-Redux with JWT tokens. And you'll also get a lot of hands-on practice. In the final module, we'll put everything together in the final project to build a front-end app with React-Redux. In this course, we'll use modern development techniques to build a React-Redux app with routing and authentication. We'll also be going deep in learning how it works under the hood. I have watched other tutorial videos that use CodePen and JSFiddle for half the demonstrations and then the text editor for other portions of the course. Both of these tools are very useful and great, but as a student I did at times feel confused because sometimes the syntax was a little bit different to the text editor and wasn't exact. To avoid any confusion, I'll do all the coding in a text editor in a development setup that you will actually use in a real world app. I'll try to also keep this tutorial as practical as possible. I'll share with you concepts and code that I ran into when building real projects. I will refrain from as much as possible from esoteric theories or edge cases that almost never come up in development. And at the same time, I'll try to share as much knowledge as I can. In this whole tutorial, including the project at the end, I'll use little to no styling. I'm creating a separate complete React styling course, which will serve as a companion to this course. So if you'd like to learn styling in React, stay tuned for that course. During the lectures, I'll periodically tell you to delete the code. I advise not to delete the code or files unless I specify so. And the reason behind this is that otherwise we will simply be rewriting the same code over and over again. And finally, finishing this course will go a long way to having professional proficiency in React. So I advise you to complete the entire course. Let's begin and create our first React app. Let's start by going in an empty directory and hitting the create React app command in the terminal. Okay, so when you're done, you should have a directory that looks like this. Let's just run our default app to see if it's working. To run our app, we can open a terminal window and then cd into the project directory. And then we can just hit the npm start command. Alright, so our app is working as expected. Now we can begin editing our app. So here are the default files that are generated by Create React App. The only directory we have to be concerned with is the source directory. We'll not be making any changes in the public directory because in there we just have our index.html file which has to be left as is for React to work properly. Let's now clean up our app and delete some unnecessary files. If you save the files, the React development server will automatically update the app. This is essentially one of the most basic apps you can have. We have an entire app that just displays the word React. And this is how we'll start. We'll start with a basic bare bones app and build up from here. Before we start coding, let's first discuss JSX at a high level. So what is JSX? What you see in the render method looks like HTML, but it's referred to as JSX. JSX essentially determines how the UI is set up. It functions similar to HTML, but JSX is really just JavaScript. And you can clearly see this because of the file that has a .js extension. If this was HTML, we would see the .html extension. So why is React set up this way? Well, to understand that, you have to first understand a concept called separation of concerns in a traditional web app. When I first started web development, there was no React and there was no such thing as single page apps. How we would structure an application in older web apps would be through a concept called separation of concerns, which basically means each part of your app should only be responsible for one main functionality. In practice, this would mean that you have a HTML file which is only in charge of the layout of the UI, a CSS file that is only responsible for styling, and a JavaScript file that is only responsible for the business logic of the app. And React goes against this pattern. React argues the UI and business logic of the app should be contained in the same file, and instead the separation of concerns should be handled through components. This means that instead of separating the app based on HTML, CSS, and JavaScript, the app is separated by components. Each component is responsible for one main functionality of the app, and we will discuss components in a later section, but this is essentially how React is set up and the rationale behind JSX. Now we can discuss some common use cases with JSX. The first is displaying data that is stored in JavaScript to the UI. And JavaScript can be written and used directly in JSX by using curly brackets. Remember that JSX is all just JavaScript, so we're really just putting JavaScript in more JavaScript. Let's create a variable called name in our app.js file and enter in a simple string. I'll write my name, but again, you can write whatever string you like. Notice that I'm not writing this variable in the render method. And also notice I'm not using either the var, let, or const keyword. In our JSX, we can display the string by using the this keyword. Then we use the variable we just created. And finally, we wrap the code in curly brackets. Do you think this will work without using the const, let, and var keywords? Let's save our file and check. And yes, you can see that we are getting the correct output. So I'll break this down and explain how it works in a second. Let's just try another way of displaying our string. Let's instead this time put our variable inside the render method. So let's first start by copying our current variable and putting it in our render method. And do you think this will work? Let's save our file and check. And no, it does not work. As you can see, we do get an error in the console. So I'll explain why this is happening, but first let's just try one more syntax. Let's use the const keyword before our variable declaration and also delete the this keyword in our JSX. Let's save and try again. And yes, our code is working again, but why? We will discuss why in the next section. In the last section, we tried 3 different ways to display a variable inside JSX, and only 2 worked. In this section, we'll find out why. To understand why, you must first understand the JavaScript concept of scopes. When we declared our first variable, we declared it in the class scope. Therefore, we did not have to use the var, const, and let keyword. Using those keywords will in fact have resulted in an error. Since we declared it in the class scope, we could access it using the this keyword in our JSX. So essentially, in our JSX, this.name means app.name, where app is the name of our class, and this refers to a single instance of the class. Name is then just a property of the class and not a variable. To test this out, let's try something. Let's console.log just the this keyword. Let's also move name back into the class scope. What do you predict will happen? Let's save our file and check. And as you can see, we get the app class, and if you expand the object, you can clearly see the name variable as one of the properties of app. And this really shows that this keyword is really just referring to an instance of our class. So let's try something else to help us better understand scopes. Let's try to access the name property outside the class. Outside of our class, we can create a new variable called app instance and then initialize it to a new instance of our app class. On the next line, we can use dot notation to console.log app instance.name. And after saving the file, we can check the console and clearly see name is printed. And to recap, the only reason we're able to see name here printed is because name is a property in our class scope. So how about our second variable declaration? Why do we need to use the const keyword when we put the variable inside the render method? And this is because when we declare the variable inside our function, the variable is no longer in the class scope, but it's now inside the scope of the function. And the render method is really just a regular JavaScript function. So you can use it exactly how you would use any other JavaScript function. And since the variable was not in the class scope, we no longer had to use the this keyword. We could just directly use the variable name. So name is now a variable inside the render method. Do you still think it will print to the console? And if we save and see, and no, we can't access the property anymore because, as mentioned, the scope changed. In the next section, we will go over how extends component in class inheritance works. In this section, we'll see how extends component works. Extends is really just ES6 syntax for class inheritance. To put it another way, the app class is extending or is inheriting the properties of the React component class. To put it even another way, the React component class is the parent class that's passing down its properties to the app child class. To demonstrate, we can console.log the whole class. So let's just delete the name property from our current console.log statement. Let's also delete our first console.log statement to avoid any confusion, and then we can save our file and go check the browser. If we look at the output, we see properties such as props, refs, and updater, and there's also a proto property, which is just short for prototype. However, we never defined these properties in our code, so where are they coming from? To find out, let's try something. Let's try removing the extends component statement and see what happens. So let's save and look at our browser. We can ignore the scary looking errors for now and just look at our console. We see that app did in fact print to the console, and because we're not extending the component class, it no longer has those extra properties that it did before. It only has a render method that we defined in our code. And this is essentially how React class components work. By using extends, the class inherits predefined properties from React, which work behind the scenes to allow the application to function. In this section, we'll go over styling and using HTML attributes in JSX. HTML attributes in JSX are written as camel case. For example, in a button, you'd use camel case to make the HTML attribute of onClick to the JSX version of onC The very widely used class attribute will actually be class name, and this is because JSX is all JavaScript and class is already a reserved keyword in JavaScript. To prevent any errors, you'll use class name, and the ID selector can be used the same way as you would in HTML. And the value of both class name and the ID attributes will be strings. There are some limitations, however. For example, you can't use CSS selectors such as :hover directly in the JSX. There is an easy workaround to this. Let's finish the button in our app class to test the :hover selector. We can create a separate app.css file in the same directory. In the app.css file, write button :hover and then the color of yellow. And then import the CSS file like so. We can save our file and go back to the dev server to see if it's working correctly. And yes, it is. So this is basically the first pattern to add styling to JSX. It's to simply have a separate CSS file for each component and then not do any styling directly in the JSX. This is probably the easiest and most effective pattern. This is one I both use and recommend. Another pattern to add styling to JSX is to create a const variable and declare all the styling in a JavaScript format. Let's go back to our app and see this. Let's now create an empty div inside our render method. Let's also create a const called styles and set it to an empty JavaScript object. In our JavaScript object, we can declare our styles. The key will be the CSS property and the value will be the CSS value. So let's create 3 CSS properties. Let's set border, text align, and box shadow. Notice that CSS properties that are separated by a dash will also be camel case. Also notice that CSS values are strings, and each property is separated by a comma and not a semicolon, such as in CSS. Because remember, this is all just JavaScript. After setting up our styles variable, we can pass them into our div with the following syntax. Style equals curly brackets styles. Let's save our file and to see if it works. And yes, it is working. There's also another pattern you might see that's similar to this, where all the styles are kept in a separate file. Let's go back to our editor and create a file called styles.js. Let's cut and paste our const styles variable to this file. Back in our app.js file, let's import this variable with the import star as styles from ./styles. As styles is user defined and we could have called styles anything. Also pass in styles.styles to the div. Remember, the first styles is referring to the user defined property in the import statement, and the second styles is referring to the single variable in the styles.css file. If we save our files, we see that it is working. In larger apps, you do something like this. You would have a variable called, for example, box styles and maybe another variable called button styles. Then instead of having to rewrite the style code in each component, you would just have one variable that holds the styles for all the buttons called button styles. And then you would just import that one variable and use it in the JSX instead of having to declare the styles in every component. And this is it. These are the 3 most common patterns you'll see for styling JSX. To reiterate, I recommend having a separate CSS file for each component. This is both the easiest and most effective method of styling JSX. Let's go a little bit deeper into JSX. Let's find out how JSX works under the hood. Let's go in our render method and console.log a div element. This code will be complete nonsense in a traditional app, but since we're working with JSX, this should work. We get this large object in the console. If we expand this on the first line, you see React.element with a type of div. This is important because this is essentially what JSX is. JSX is simply the function React.createElement being called over and over again behind the scenes. And let's set up an example to see how this works. Let's go back to our editor and delete everything except our React component code in an empty div. Inside that div, let's use the curly brackets to write some JSX code. Write the following code in the curly brackets. React.createElement and then parentheses, and then first a string of div, comma, curly brackets, class name, and then a string of app, and then finally just a string of React your name, and then close off the parentheses and the curly brackets. Let's save our file and see what happens. And yes, our code is in fact still working. And just to really be sure, let's change the string of div to the string of button. And if we save this, we should now be seeing a button. And yes, this is exactly what we see. This concept is important to understanding how React works under the hood. React uses what's called a virtual DOM, which is essentially a representation of the DOM underneath, but is not the actual browser DOM. The div in the React create element function is actually referring to a React element which is representing the div, but this is not the actual HTML div. How this div JSX code is converted to the normal create element function JavaScript code is through the Babel plugin for Webpack. And this is all default functionality we get right out of the box with Create React App. We don't have to set anything up. We don't need to do a deep dive into Babel in Webpack right now, but Babel essentially turns our ES6 and ES5 JavaScript code into basic JavaScript that is readable by all browsers. ES6 and ES5 JavaScript are just newer versions of JavaScript that make development easier, meaning it's easier to read and write code for the developer, but browsers can't directly read the newer versions of JavaScript code, so essentially we use Babel to convert ES5 and ES6 code back to basic JavaScript. And again, it's not necessary to understand how this process works at a deep level, but a basic overview is fine. And we can actually see how this works exactly by going to the Babel website and using their try it out tool. So let's go to the website and try it out. So go to babeljs.io. Let's click on the try it out tool and check the React box. And let's type in our JSX from our React app. If you copy div class name app and then the word React, the output you'll see is the same React.createElement function that we just went over in the last section. So cool stuff. So basically what this allows React to do is compare the virtual DOM to the actual HTML DOM and only update the HTML DOM elements that have changed. And this is why React is referred to as a single page application. It's literally only a single HTML file. When you first visit the site, the server sends you literally all the code for the website, and you stay on a single HTML page no matter what you're seeing rendered to the screen. If we go to our React app and under the Elements tab on DevTools, you can see there's a div with the ID root. For every React application, literally all the code is contained within these two divs. Even apps with thousands of lines of code and hundreds of components, all the code is within these two divs. And all the code is sent to your browser in one HTML file. There are techniques such as lazy loading to help with the initial load time for larger apps. So just to explain this a little bit more, essentially the server responds with one HTML file. The contents of head and HTML elements never change, so the DOM elements always stay the same. Only the code within the div ID root changes, and that's really what's displayed to the user. And we can actually see this in real time. Let's go back to our app.js file. Let's delete everything except the app.js and index.js files. Let's declare a new property called state and give it a property of counter. And let's set counter to 0. Next, let's declare an arrow function called increment in the code block and use setState to change the counter to 5. We'll discuss state and arrow functions in later sections, but we can skip them for now just for the purposes of this demonstration. In the render method, let's make 3 new divs and add a div with the number between each of them. And let's create a button that calls the increment method we just defined using the following syntax. And finally, let's add this.state.counter to the first div. Again, we'll go over this code in more detail in a later section, but let's just use this code to demonstrate how the virtual DOM works. We can now save everything and go back to our dev server. Open the DevTools and go on the Elements tab. Expand the divs so all the text and divs are showing. And let's click on the button. You will see that only the first div changes and everything else remains the same. This may seem like a simple example, but this is literally how React fundamentally works. Even in extremely complex apps with API requests or other asynchronous actions, under the hood, this is basically all that's happening. Even with apps with routing, this is how it's done. When a new route is requested, only the parts of the DOM that have been changed are updated, and everything else is left as is. And obviously, this results in huge speed improvements compared to traditional web apps. And just to expand on that point a little bit further, in traditional web apps, every route change requires a new HTML page that has to be requested from the server. And of course, this results in obvious lag and wait times while navigating the website. It is possible and actually standard in single page apps to navigate the entire website, including sending messages, writing blog posts and comments, and uploading files without ever having to reload the page. And again, the speeds are comparable to offline desktop apps. And this is why traditional web apps compared to single page apps seem archaic and slow. And the difference is extremely noticeable in mobile web surfing. So even though we're talking about only a few difference of a few seconds, modern consumers simply will not put up with the slower traditional web apps when there are single page apps available. And this is why I think single page apps will be the future of web development, and traditional web apps will be slowly faded out. So now we can discuss working with JavaScript objects in JSX. And you have to understand how to correctly display objects in JSX. This is a problem I guarantee you'll run into sometime during development. So I've cleaned up the code from the last section. So let's create a new const inside of our render method called var1. And let's set the value of this variable to an object with a key of key1 and a value of a string. Let's just call it some data. And let's also try to display this object in our render method. If we save and look back at our dev server, we will see we're getting this error message of objects are not valid as a React child. And this error may seem confusing and strangely worded at first, so let's explore this a little bit. We can also go under the hood and see exactly what this error message is trying to say. Let's go back to our app and convert the JSX back into a function. Let's return react.createElement and then a string of div, class name, string app, and then a string of some text. And again, this React create element function is something we went over in the previous section. And remember, some text is a child of the div element. If we save now and go back to our dev server, it should be working as normal. However, let's change the string of some text to var1. If you save, you'll see you'll get the exact same error as before. So this error is literally saying that the child of the div element cannot be an object. And the solution to this error is very simple. Instead of trying to display the whole object, simply access only one key. Let's go back to our editor and add var1.key1 to the JSX. If you save, you'll see that our text is now displayed. And just to show you the regular way, this is curly brackets, so var1.key in the JSX. And this is essentially how to display objects in JSX. Instead of trying to display the whole object, you'd have to access each property of the object separately. And I guarantee this is something you'll definitely run into during development. So let's first define props. Props is really just short for properties and is essentially a way to pass data from a parent component down to a child component. And this is also known as one-way data binding. This is in contrast to two-way data binding that is seen in frameworks such as Angular. In Angular, two-way data binding is implemented where the controller passes data to the view. Basically, this means JavaScript passes data to and updates the HTML, which is very common. But in two-way data binding, the view can also pass data back to the controller. So this means the HTML can update the JavaScript, which is not as common. And React goes against this pattern. A child component in React can't pass a prop to a parent. So one-way data binding essentially means props are read-only. Now we can discuss components. Components in React determine essentially what the user sees on the screen of their browser. Components come in two different varieties: functional components and container components. Containers are also referred to as class-based components, and class-based components must have a render function that returns some JSX. Functional components return JSX directly. Containers can also be aware of and change the component state. We'll discuss state in depth in a later section. Functional components can't have a state, and both components can have optional props. So some use cases for class-based components would be for more complex components that have user events and interactions. Functional components are mainly used for rendering data to the screen and are generally read-only. So let's go over an example to see how this works in practice. I will quickly go over the setup and then explain everything afterwards. Let's delete everything except for div with the word React. And let's create two new directories, a functional directory and a container directory. There are many different ways to structure a React app, but I found separating functional and container classes to be the most useful. Let's focus on functional components first. In the functional directory, create a file called component1.js. In this file, we'll create our first functional component. So as I said, I'll just write the code and then explain it afterwards. Functional components are usually set up with the ES6 arrow function with the const keyword, followed by a parameter of props, then two parentheses that contain the JSX. We can then import this to our app.js file. In a render method, we can simply write the functional component as if it were a HTML element. And if we check, we should be seeing the component one, and we do. So let's break this code down, starting with the functional component. First, we only have to import React at the top. Since this is not a class component, we don't need to import the component. Next, we're declaring a basic arrow function. Since there's only one parameter, we don't need parentheses around props. Also, we wrap the body of the code block in parentheses instead of the traditional curly brackets, since we're just returning simple JSX. Wrapping the code block with parentheses is equivalent to writing curly brackets return JSX. Finally, at the bottom, we're exporting default. Default is a keyword that allows us to import component1 as simply component1. If we didn't, we would have to use the curly brackets in our import statement in app.js. Also important to keep in mind that all components must be uppercase. This helps with code readability since all HTML JSX elements are lowercase and components must be uppercase. This is not only convention, but not doing so will result in an error. So this is it for our first functional component. In the next section, we'll look at props. We can now go to our app.js file and set up our first prop. Setting up a prop is very similar to setting HTML attributes to JSX elements. In the component1 element, create a property of name and set it to the value of string of your name. With this setup, we can now begin to see the parent and child prop relationship. This pattern is known as component nesting. The component1 child is nested inside the app.js parent component. Another way to visualize this is imagine app wrapping the component1 element. So accessing the value in these props is now very straightforward. The name prop can be accessed from the props keyword we defined in the parameter. Simply access the prop with props.name in the JSX. If we save the file and check the dev server, you'll now see that name is displayed from the prop. We can also have more than one props per component. Let's create another prop called age and set it to 25. And if we check, we see that it is working. And this is really it for displaying props in functional components. In the next section, we'll look at displaying props in class components. Now we can go over setting up props in a React class-based component, which is referred to as a container. Using props in a container is a little bit different than using props in a functional component. Let's first create a container file in our containers directory. Go into your container file and import React at the top. Next, create the class and add extends component to the class. We also need a render and return statement, and we could finish it off with an empty div. Finally, we need to export the class at the bottom. We can now import it back to our app.js file and declare it in our app.js in the same way as our functional component. Let's add a prop called nickname with the value of string. How we use props in class-based components is the same as functional components, except that we need to add a this before props. Then we can just use dot notation to access the value of the property. If we save everything and look at our dev server, we see that it is working. We can also look at our React dev tools. If you click on the arrow in the dev tools, you'll also see a React option. If you click on a React component, it will list out the props for you. It will also tell you the state, which we'll see next. And this is it. This is all there is to props. In the next section, we'll look at another main part of React known as state. So what is state? Conceptually, state is just temporary data, and the keyword being temporary. Let's first look at examples of non-temporary data to understand state better. Examples of non-temporary data would be things like blog posts, comments, and user profile information. Non-temporary data is stored and retrieved from a database, which is either SQL or NoSQL. Now that we know what non-temporary data is, we can discuss temporary data. Temporary data would be things like whether a user is logged in or not, what page a user is on, and whether a dialog box is open or not. These are pieces of data you would not store in a database because it would make the user experience very slow. Imagine having to retrieve data from the database every time you wanted to open or close a pop-up box. That would be insane. So that's the purpose of state. It's a way to store and update temporary data. More specifically, state in React is stored in a JavaScript object. Each property of state is a key in the object, and the value can be any data type, such as a string, number, array, or even another JavaScript object. State is only accessible by the component it's declared in. State is not accessible by the parent component or any other component in the app. Unlike props, state is both read and write. The state can be changed in the component it's declared in by a special React method called setState. As we discussed previously, React looks for changes in the virtual DOM and then changes the real DOM underneath. And this is true for state as well. Calling setState will cause the component to re-render. You must initialize all your state properties beforehand. State is initialized in the constructor. You can set the value of the state property to an empty string, null, or an empty array. You can also set any default value that you want for state that isn't null or an empty string. And again, all your properties must be initialized in the constructor. You can't create a new state property in your render method. And look at this slide and really try to understand state conceptually. If you think you got a good grasp of it, we can start writing some code. Let's go to our container 1. Let's begin by writing the constructor function. Remember, the constructor function is not React specific or even ES6 specific. It's part of vanilla JavaScript, and the constructor function initializes the class. Next, we pass in props as an argument, and this is React specific, and the props are the same ones we went over in the previous section. Next, we have to call super. This is again part of vanilla JavaScript and required code. The super method lets us access the properties and functions in the parent class. For us in React, the parent class is a React component. Not using super in your constructor will result in error. And again, props are React specific. After this, we can initialize our state. First, state is created by using this.state, then equals a JavaScript object. The properties here are all user defined, and we can make them anything we want. Let's create a property of state called stateProp1. We can set the value of this property to anything we want as well. For now, let's just set it to a string of our initial state. To reference this value in our JSX, we can use syntax that is very similar to displaying props. We can simply go to our JSX and enter curly brackets this.state.stateProp1 in between two divs. If we save everything and look in our browser, we can see that yes, indeed we do see this string we set up in our state. In the next section, we'll discuss how we would change the state. I'll first give you a high-level overview of changing state, then we'll see how it works in code. Changing the state in a component is done through the setState function. This is a React-specific function. We're given this function by default, and there are three main aspects you must understand about changing state. First is do not change the state directly. Second is changing the state by referencing the previous state. And third is React will merge the old state with the new state. Let's go over the first aspect, which is do not directly mutate state. This is one of the most important concepts of React. In other React tutorials, you will hear this phrase over and over again because it bears repeating. Do not directly change the state. Let's see what this might look like in code. Let's create a function called changeState. In the body of the function, let's set our state property to a new string. Again, this is the incorrect way to do this, so let's write wrong as a comment on top of the function. And let's set state to a string of new state. In our JSX, let's create a button called changeState, and one click, this button will call our changeState function. If we save everything and go back to our browser, we can clearly see in the DevTools that on line 14, there's an error saying that we can't directly mutate the state and must use the setState method. Clicking on the button does not do anything, so clearly this is the wrong way to update the state. Let's go over the correct way to do this. Let's use the setState method. In the changeState function, call this.setState. Inside the parentheses of setState, add curly brackets. Now we can simply set the state property to a new value. Let's set the value of the string to new state. And let's change the comment to correct since this is now the correct way. If we save everything and go back to our browser, we see that yes, it is working as expected. Clicking our button does change our UI. It's possible to also call setState directly in the JSX. Copy the setState method and paste it inside the onClick arrow function. If we save and check our browser, this will work as expected. This isn't recommended though because it makes code readability worse. Calling setState method inside a function makes your code much easier to read. In the next section, we'll go over the second aspect of state. So let's go over another aspect of changing state, which is changing the state by referencing the previous state. Let's go through an example to understand how this works in practice. So refactor your code to the following. In this code, we're essentially using an arrow function inside of our setState method. Pref_state is the previous state and props contains the props. To test this new functionality, let's create a new property of state called stateProp2. Instead of a string, let's set this property to the number 5. In our changeState method, we can delete stateProp1 and change it to stateProp2. Then for the value, we can set it to previous state.stateProp2 plus 1. We could also increment it using pref_state.stateProp2++, but to make it more readable, I'll just use this syntax. Finally, in our render method for our JSX, we can just change stateProp1 to stateProp2, and also call our changeState method from the button. Let's save everything and check our browser. And yes, it is working as expected. Let's also try another syntax. Let's delete the arrow function and just update the state without passing in the previous state in as an argument. So this.setState and then stateprop2 equals this.state.stateprop2 plus 1. If we save everything and check our browser, we see that it does work and we're not getting an error. And this is valid syntax. It may look like we're directly mutating the state, but we're actually not. This.state.stateprop2 is a reference to the state and not the actual state we are changing. We are still using the setState method. For that reason, this is valid syntax to update the state. You'll notice in our last example, we did not have to set our first state prop1 when calling our setState method. And this is the third aspect of updating state. React will merge the old state with the new state. This means that if you change one property of state, the other ones are not affected. To see how this works, let's create another function called changeState2, and let's keep our first changeState function as is. In the second function, let's use string concatenation to add a L to the string of state prop1. Let's also create another button to update the second state property and keep the first one as is. And let's also display state prop1. Let's save everything and go back to our browser. If you see that clicking each button updates the corresponding state prop, clearly this shows that React automatically merges the state behind the scenes. If it did not, each state prop would go back to its original default value whenever we click the opposite button. In summary, this is essentially how you would update the state if the state has more than one property. In the setState, only update the single property you want to change. React will make sure behind the scenes that the new property merges with your old state. So there's also a couple of more smaller nuances about changing state that you should be aware of. So far we've been updating one state property at a time, but it's also possible to update multiple properties in the same setState call. Let's try this. Let's copy the code from the changeState2 function and copy it into the first changeState function. We would not use a separate code block for the second state property. You would just separate them with a comma. If we save and see, we do see that it is working. Another small point is that you're not limited to using setState with a certain property only once. We can keep the code as is, and if we click the second button, the state updates as it should. So we can update the same property in multiple ways. If we call setState on a property once, we can also call setState again on the same property in a different method. There's nothing stopping us from doing this. So another thing you can do with state is pass it down as props to another component. Go ahead and import component1 and declare it in the JSX. Next, we can add a new prop to component1 called prop1. We can then set the value using this.state.stateprop1. And let's also clean up our code a little bit. Next, we can go to our component1 file and use the value of the props using curly brackets props.prop1. If we save our file, we see that it is working. This isn't really a recommended pattern, but just something to be aware of. In this section, we'll go over how to conditionally render JSX. I'll first show you the beginner naive approach, then the modern ES6 solution. Then I'll show you another vanilla JavaScript solution. If you wanted to conditionally render data, your first thought would be to just use an if-else statement. Since this is all just JavaScript, this should in theory work. Let's go to our render method and define an if-else statement. Let's also clean up our code a little bit from the last section so we only have the word React rendered to the screen. For the conditional, we can just put true and then return a div with the text of condition 1. Our else statement can be the same with condition 2. If we save our code, we do see that it is working. Changing to false gives us the expected result as well. Like I mentioned, this is not the recommended approach to doing this. We will instead use a ternary expression right in our JSX. The syntax for a ternary expression is curly brackets, the condition, either true or false, question mark, and then followed by the code block to be executed if true, colon, and then the code block to be executed if false. It is essentially an if-else statement with a different syntax. Let's delete our if statement and write a ternary expression. In the JSX, write the ternary expression to match the syntax of our if statement with the model I gave you. Try to figure this out on your own, and I'll see you in the next video. So hopefully that wasn't too hard. Here's the answer if you weren't able to get it. So let's save our file and go back to the browser. And as expected, our code is working. We can also do a nested ternary expression similar to a nested if statement. Let's try this in our ternary expression. And let's first separate our ternary expression into multiple lines. The most readable structure, in my opinion, is to have the condition on the first line, the first code block on the next line starting with the question mark with an indentation, then the second code block starting with the semicolon on the third line. In my opinion, this makes the code the most readable, but again, you can structure the ternary expression however you want. After this structure, we can use the same exact syntax to create another ternary expression inside of our first ternary expression. If we save and look at our browser, we will see condition 1. So how do you get condition 3? If you guess false, then true, then you're correct. And let's save and check. And yep, it is working. You can also triple nest this ternary expression for fun, but you should get the point by now. But just as a challenge, try to triple nest a ternary expression. And one hint is that you should have 8 conditions. Let's delete all this code and go over a final way to conditionally render content. Let's create a function called renderFunction1. In React, it's convention to name functions that return JSX to render, and then a word to describe what the function renders. To keep the theme consistent with what we've been doing so far, in the code block, let's return a div with condition 1 and condition 2. To use this function in our render method, we can simply call the function in our render method. Where you call this function is important. Let's create two new divs and call them div1 and div2, so we can see that where calling the function matters. Let's first call the function after div1, so if we save, we should see condition1 written under div1. And yes, this is what we see. Then if we cut and put the function call under div2 and save, we, as expected, should see condition1 under div2. And yes, this is what we're seeing. Just as a quick side note, I haven't used this in any of the examples, but you can return multiple lines of JSX simply by wrapping the lines with parentheses. You don't have to use JSX in your conditional statements either. You can simply return null. And second, you can also pass in entire components by importing them and passing them into the code blocks. And you can also pass JSX and a component together. So in summary, these are the three ways to conditionally render data in JSX. Method 1 is not used very much, and I don't advise you to use it either. Method 2 and 3 are both good. I personally like method 2, and I almost use it exclusively in my code. You can make the argument that method 3 improves code readability, but I don't know about that. Either method 2 or 3 is good. We can now discuss lifecycle methods. To avoid any confusion, I'll talk about the two main and most used lifecycle methods, but you should know there are 6 or 7 total lifecycle methods depending on which version of React you're using. However, the other lifecycle methods are used so rarely that you're better off not learning them to avoid any confusion. We will discuss only the component did mount and component will unmount methods. Luckily, these two methods are also the easiest and simplest to understand. I didn't know this beforehand, but even on the official React docs under the lifecycle section, only these two lifecycle methods are even mentioned. The other lifecycle methods are never even brought up in the official React docs. So again, I only noticed this after recording this lecture. So this really reinforces that you really are better off just learning these two lifecycle methods. Let's begin with an overview of the React component lifecycle first. The very first part of the lifecycle is called the mounting phase, and your immediate question would be, what is mounting what? Remember that if we go back to the diagram we saw earlier in the section, we saw that React is built on a virtual DOM, and that virtual DOM sits on top of the real browser DOM. And by comparing the changes with the virtual DOM, the real DOM is able to update the UI. So in essence, the React virtual DOM is mounting the real browser DOM. In a React class-based component, the very first thing that's called is a constructor method. The constructor method initializes functions, variables, and the component state. And next, the render method is called. If successful, our next lifecycle method is the component did mount method. And this is the first lifecycle method we'll discuss. This method is simply saying the virtual DOM of the component successfully mounted the real DOM. This is basically the method where you want to put functions you want to call immediately when the component is rendered. After that, you have async operations such as database API calls. Finally is the component will unmount method, and it's called blast. And this is basically saying the component is unmounted from the real browser DOM. To put component did mount another way, you will use this method to perform an action that you want to happen automatically right when the UI appears without the user having to manually do anything. The most obvious use case for this is an API GET request for maybe retrieving a bunch of blog posts for a forum. When you visit your favorite blog, you don't click on a button to have the post retrieved from the database and displayed on your screen. This all happens automatically, and this is the main purpose of the component did mount method. I've personally used this method constantly in development and production code. So basically the component did mount method is used when you want to have something happen automatically when the user visits a page, or you can say renders a component. Also something to note that after the mounting phase, there is an update phase. There are lifecycle methods for this phase, but you can easily achieve the same outcome with state and conditional methods. And again, the last phase is the unmount, when the component is basically going away. I personally rarely use this method simply because I never had a reason to. Really, if you think about it, anything you would want happen here can be more easily done in the component did mount method of the next component. A couple of use cases I could think of would be maybe an outro transition or an animation of a component, and also maybe updating state because maybe it's important that the user is no longer on this page. This is just an overview. We will use these methods in code in the React router section. In this section, we'll cover working with arrays. We'll create an example array to use for this section. We'll use an array of JavaScript objects since this is the most likely array type you'll see in development. Arrays with single values such as only strings and only numbers are not really seen very much in real development. Let's go to our container.js1 file. If you have not already done so, let's delete everything except an empty div. Let's create an array of 5 elements of JavaScript object, and let's give each object a property of ID, text, and number. Since we're working with React, this entire array will be one property of state called R1. The next thing we need to do is create a functional component to display each of our JavaScript objects. This functional component will essentially be a skeleton structure of how each element is displayed. You generally create this component in the functional directory, but for our demonstration we can just create it here, and we can leave it in empty div for now. The standard way to render a list of items in React is by iterating over each element and passing each element as an argument to our render list item component. In vanilla JavaScript, iterating over an item is done with the for loop. We're going to use modern ES5 syntax and just use a .map statement and an arrow function. So the .map function is a modern for loop. It iterates over the array and performs a function on each element. In the map function, we can use the arrow function and set the parameter to item. This item contains the JavaScript object we declared in R1. Before going over the solution, let's just console.log our item parameter and see what we get. And great, we can see that our map statement is doing exactly as intended. We're getting each element of the array printed to the console. Another thing you might find useful is we can easily access the index of any element. Simply pass in a second argument after the item keyword and wrap it in parentheses. You can call this index or I, but you can actually name it whatever you want. It just has to be the second argument. We can console.log index, and we indeed see the index of each item printed to the console. The map statement also has an optional third argument, which you can use to access the whole array. It's not used that much, but just something to be aware of. Now that we know how the .map statement works, we can use it to render a list of elements. Simply pass in render list item in the code block of the arrow function and pass each element as a prop. You can name the prop anything you want, but it's convention to name it the same as the parameter you set in the arrow function. Now, since we're passing each element in as a prop, we can simply just use it as a prop. Also, be sure to add the this keyword before render list item. The syntax may look weird, but it is valid. We can now go back to our render list item element and modify the code to work with our map statement. The entire JavaScript item object is contained in our props. As we saw in the last section, we can't directly render JavaScript objects. We have to set each property separately. So we can just access each property with props.item.text or whatever the name of the property you want to access. And we can do this all here in our functional component. If we save everything and go back to our browser, we can see that it is in fact working and rendering our list of items. If we look at our console, we do see an error that says each child in the iterator should have a unique key. In React, when you're rendering a list, you must explicitly set a unique key for each element as a prop. Setting a unique key is important because it allows the React virtual DOM to keep track of what elements of the array have been changed, added, or removed. Your first thought would be to just make the index of every element the unique key, and this will make the error message disappear, but according to the official React docs, this will result in complex errors down the road and is not recommended. The unique key must be contained in the element itself. For our example, we can use the ID property. To set the unique key, we can pass it in as a prop to the render list item component. If you save everything and check your browser, you will see that it is working correctly and we're no longer getting the error. And this is it. We've correctly rendered a list of items. In this section, we'll go over how to set up forms in React. Setting up forms in React is not exactly straightforward, and there are a few nuances you have to be aware of. Let's go to our container one and create a basic HTML form. Let's also start fresh and delete all the code except for an empty div, if you have not already done so. In our form, let's use the label of name, and we can have one input with the type of text. Let's also create a submit button before the closing form tag. We can add a little bit more code to make our form more complex. In a regular HTML form, the input text area usually takes a onChange event, and this is similar to the onClick event for a button, and it's an event we use with JSX. The onChange event does exactly what its name describes and calls a function every time a new keystroke is entered into the text box. To actually submit the form, we can specify the submit to an attribute of type in our button. As an attribute of form, pass in the attribute of onSubmit and set it to an empty curly brackets. So in our class, we need to define two functions. One to handle the onChange attribute in the input text area, and one function to handle the entire form submit. React convention is to name these functions handle change and handle submit, but of course you can name them whatever you feel appropriate. I'll first show you the modern way to set up the form, and then I'll also show you an alternate syntax that you may see in legacy code or older tutorials. Both ways work and are valid. We can leave handle submit empty for now and start with handle change. Let's look at our render method and pass in the function handle change. In our attributes, the syntax is a little different than we're used to. We don't actually call these functions, we instead pass a reference to them. This allows us access to the synthetic event, which we will discuss next. Let's also comment out handle submit and take away the onSubmit event for now. So how do we access the data in this form? And the answer is through the event keyword. This event keyword is not React specific, but part of vanilla JavaScript. We access it by passing it in as a parameter to our function. In the code block of our function, let's console.log the event keyword and see what we get. And let's save everything and check our browser. So begin by typing in the text area. You'll immediately see something called the synthetic event being console.logged. If you expand it, you'll see it's a pretty big object, and we don't need all this data. So to get only the value of the input, the standard way to do it is event.target.value. If you see now, yes, we are only getting the input of our value. Setting up our handle submit function is a little bit different. First, let's add an ID attribute to the input name. Let's now go to our handle submit function and add event.preventDefault. This is also a given JavaScript function and basically prevents the browser from reloading every time we submit a form. Since we're using a single page app, reloading the browser does not help us and actually resets the state. Accessing the input value is also a little bit different. Instead of event.target.value, we use event.target.name.value. And again, name is just the ID attribute supplied to the input element. And also remember to pass the reference to handle submit in the onSubmit event of the form. If we save our code and go back to our browser, we can test this out. Only enter one letter in the text area for now and hit submit. And yes, it is working as expected. Our value is being printed to our console and our browser is not reloading. We can access both the input values and our form is working as we expected. Unfortunately, we're not done yet. See, our form now has its own temporary data. And as we know, temporary data is state. We are not using the setState function anywhere in our form or functions. This means that we have two different states in our component. In React, this is bad practice. In React, we must have only one source of truth, so our form has to basically work through the React state. And this concept is known as a controlled component. Setting it up is not that complex. Let's initialize some state. We can forget about the constructor for now and just use the state as a standalone property. So in React convention, we first create a property of state called value and then set it to an empty string. Next, let's think about how we would implement this. We are really only going to change the state when the user enters the text. So we really only need to use setState in the handle change method. We can access the input value the same way, so we can just set the state property of value to event.target.value in our setState method. And just to test if everything is working, let's also display the state to our UI. Let's save our code and test the browser. And yes, it does seem to be working. In our handle submit method, we only need the final value of the input when the user submitted the form. We can do this simply by accessing the state property since it will be the same as what the user intended to submit. So we can just change our console.log to this.state.value. Let's save everything and test our app. And yes, it does seem to be working. We're done setting up the controlled component. In a real app, you'd use maybe an API request in the handle submit method to save the form data to a database. I'll also now show you an alternate syntax for creating forms in React. You might see this in legacy code. This approach isn't used very much since it's much more simpler just to use an arrow function, but you might still see this somewhere. So let's first start by changing our arrow functions to regular functions. If you save the code and test the app, you'll see it no longer works. Because in the code block, the this keyword is now referencing the function instead of the class. The solution to this is to first start with the constructor and the super method. The syntax to make this code work is this.handleSubmit equals this.handleSubmit.bind, and then pass in this in the parentheses. And this is also the same thing for the handle change function. This basically correctly assigns the this keyword back to referencing the class instead of the function. We didn't need to do this before in our original code since the arrow function solves this problem for us automatically. Let's save our code and see if it works. And yes, it is working. The syntax is valid and will work, but again, the recommended approach is just to use arrow functions. Before discussing what Redux is, we can go over why we need Redux. So as we've been learning in React, state is one of the core concepts, and state can be updated in the component in which it was initialized in. However, what if we want to update the state and have it persist to other components? For example, if we were to implement authentication, we'd want all the components in our app to be aware of this. You might try to do this with props, but as we mentioned, props are one-way data banding. We can easily implement if users logged in and then pass that data down as a prop to a child component. But if a user logs out, it would be hard to update the parent component from that child component. To create a sort of global state where the state can be updated and persist to all other components, we use a state management library such as Redux. Redux is a standalone library. It's not affiliated with React at all. It can also be used with other front-end frameworks such as Angular and Vue. In Redux attempts to make state management predictable and easy to manage by using a few constraints on how state can be updated. Without these constraints, state would have to be mutated directly, which would lead to instability and unpredictable state changes. We'll discuss these constraints as we explore Redux. So the first principle of Redux is there's only one source of truth, meaning that your entire application state is stored in one object. This just makes state changes more predictable and it allows for easier debugging. This doesn't mean that all your Redux code will be bunched up in one file. We'll see how to split up and organize our code without violating this principle. So the second principle of Redux is that state is read-only. This is meant to convey that similar to React, we can't directly mutate the state. Obviously, we can change the state, otherwise Redux would be pointless. But similar to React, state is updated in a special way, which in React was through setState. Redux updates state in a special way as well, through something called actions, which we'll discuss shortly. So the third principle of Redux is that changes are made with pure functions. This one's a little hard to understand before you've worked with Redux, but it's essentially saying that the final state produced has to be from simple, non-asynchronous functions. State is outputted in Redux through something something called reducers, which are functions that this principle is referring to. Reducers are set up as case switch statements. Each case statement must simply take a copy of the previous state and output a new state. The previous state isn't directly mutated, and the state case statement can't be asynchronous or do anything else besides just taking in the previous state and simply returning a new state. And this is what pure is referring to. All the asynchronous and complexity has to be handled in the actions. In this section, I'll provide you with the basic building blocks of Redux. We'll not be doing any coding in this section, and it's because, as mentioned, Redux is a standalone library. You can write only Redux code without any front-end framework, and this is not what we're going to do. We're going to be using Redux with React, and to make them work together, we'll actually use a third library called React-Redux. And this may seem confusing, but React-Redux is a library separate from both the React and Redux. And this library has its own docs on its own website. It's completely separate. But unlike the React and Redux library, the React-Redux library has only one function and can't be used independently. And its only purpose is to hook up React with Redux and allow you to use both React and Redux separately. We will use this third library called React-Redux to write the actual code and build the app. And since we're using that library, we won't be writing any pure Redux code. So therefore, to avoid any confusion, I won't be doing any Redux coding. We'll just start off with React-Redux. If you're curious though, I highly recommend visiting the Redux docs. So, if I were to teach Redux code here, you'd basically have to unlearn it immediately after you just learned it, and then use the React-Redux code. There is some overlap, but you're better off just starting with the React-Redux side. And in the following sections, I'll be showing you snippets of code. Don't worry about the exact syntax of the code. Instead, just use the code to help you understand Redux better conceptually. And here I've included a table that shows you how to read and update the state in these three separate libraries. If you're ever confused, just refer back to this diagram. So with that out of the way, we can now discuss Redux. As alluded to earlier, Redux has two main parts. It's actions and reducers. We'll look at how actions and reducers work together, but first let's start with actions. So what is an action? An action is literally a JavaScript object. It has one type property that's a string, and it describes how the action will update the states. And actions are passed into Redux with the dispatch action function. This dispatch function helps pass the action through the reducers under the hood, and therefore we say actions are dispatched. And as an example, an action with the type of login success might change a property of the Redux state called is authenticated from false to true, which would signify that a user has logged in. Actions can also optionally hold any other property as well. For passing in data, the property is usually called payload, and the data can be passed in as an argument to an action creator. We'll discuss action creators in the next section. We can now discuss action creators. Action creators are just functions that return actions, and they're not a separate building block of Redux, but instead just an alternate way to dispatch actions. And they're useful if you don't know the data you want to pass in the reducer beforehand, and they're also used for asynchronous actions. For example, if you want to save the user input to state, you would set up an action creator with the arrow function as shown below. And again, this is not working code, but just something to give you an idea of how it might work. And now we can discuss reducers. Reducers are pretty much set up as a switch case statement, and each case statement represents a single action type. Each case statement must match an action type. There must be a straight one-to-one relationship between actions and reducer case statements. There can't be more actions than there are reducer case statements, and vice versa. When an action is dispatched, it's run through the reducer to see if there's a matching case statement. If there's a matching action type in the reducer modifies the global state accordingly. And this is all done under the hood. And as mentioned before, reducers can't be asynchronous. They must simply take in the previous state and return a new state. So all the asynchronous actions have to be handled by dispatching actions. For example, using the example we just mentioned, an action type of login success will automatically be run through all the reducers if there's more than one, until a case statement in one of the reducers matches the action type. It might be a auth reducer that contains a login success case statement. When there's a match, the code inside the block is run of that case statement, and usually there will be a spread operator that will make a copy of the current state and then just change one property to the new value. After the reducer's return statement, the new state is outputted. This is now the state that can be accessed in any component. In React, if the Redux state changes, the component is re-rendered automatically thanks to the React-Redux library. And it stays this way until another action is dispatched and the state is updated and the cycle repeats. Clearing the state is done through actions as well. Simply call an action such as remove state, and in the reducer simply set the property to an empty array, empty string, or just null. And the exact same process will occur that I just mentioned. And this is how to remove the state without mutating the state directly. And this is it. If you understand this, you really understand Redux. And it's important to get a good grip on Redux before moving on. And I highly encourage you to redo this section until you really understand it. Redux was one of the hardest things for me to understand, and for a lot of other people as well. There's no shame if you didn't get it on your first try. Just stick with it until you really understand it before you move on. Let's get started and build a very simple app with React and Redux. This app will have only 2 plain actions and 1 simple reducer. We will not worry about action creators or multiple reducers for now. Let's use the same app we've been using before in our React app. And let's also create a new directory called store. In this directory, let's create 2 new directories called actions and reducers. Let's also delete everything so we only have the word React appearing on the screen. We will start by setting up the actions. In the actions directory, create 2 files called actiontypes.js and actions.js. I'll start with a very simple example to show you how actions and reducers work. In the actiontypes.js file, create 2 action types called a string of success and a string of failure, all caps. And just to break this down, we've created 2 variables called success and failure and set the value of these variables to the string of success and failure. And we use a const keyword because we're not going to change the value of these variables. And we use the export keyword because we'll be using these variables in other components. Now in your actions file, import the action types and set the type as follows. Create a new export const success JavaScript variable and set the type to actiontypes.success. Doing this may seem redundant. For example, you can simply set the type to the string of success, but using a separate action types file is considered a best practice and a recommended approach to setting up actions. We will also import and use these action types in the reducer. In larger apps, this would become complex if we were only using strings, because if we wanted to rename an action type, we would have to track down every time it was used and change it in every component. By having one file that has all our action types, we can easily look it up and change the action types. And this pattern greatly reduces errors. Now let's create a new file called reducer1.js in the reducers directory. And here we'll create our first reducer. Let's first import our action types from the actiontypes.js file. And we'll start off by setting a variable called initial state to a JavaScript object. We don't need to use the export keyword since we'll just be using this variable in this file. So this JavaScript object that we just created is what's considered the actual Redux state. The properties and values are user defined and we can make them anything we want. We also don't have to start with a negative or empty state. We can hard code an array of strings or numbers or make the initial state whatever we want. For now, let's just create a property of state called stateProp1 and set it to false. Next, we have the switch statement. The root reducer will be a const variable with the name of the reducer as the function name. With ESX, the reducer is also an arrow function, and the reducer takes two parameters, state and actions. These parameters are reserved keywords and are not user defined. We set the state parameter equal to the initial state variable, and again, setting default parameters is also ES6 syntax. Now we can set up our switch case statement. We're just using JavaScript dot notation to access the type property that we set up in the action in the last step. And this was, again, remember, just a string of success. And a switch case statement is really just an if-else statement. So this reads as check the action.type property, and then the case statement means if the action type is success, run this code block. Each case statement is a type of action, and each case statement must be a type of action you defined in the action types file. And this case statement can't have any other value. At the bottom, you have a default statement that returns the original state with a spread operator. If an action is dispatched that matches the type in the switch function, then as you can see, we first use the spread operator on the current state. This both flattens and creates a new copy of the previous state. The spread operator also allows us to change a single property of the JavaScript object, and which we can do simply by setting stateProp to the value of true in the first case statement. We're also not limited to changing one state property at a time. We can change multiple state properties with one action. And finally, we just export our reducer at the bottom of the file. We're not done setting up the reducer just yet. We still need to set up the reducer in our index.js file. This will make our state available globally in our app. The first thing we need to do is import all of our dependencies. To save time, I've already done this. And also be sure to install Redux and React-Redux if you have not already done so. We then create the store with the Redux's createStore function. We'll pass in the reducers as an argument, which is the same reducer we set up in the last step. Next, we use a provider component from the React-Redux library, and we wrap our app component with it. Be sure to pass in store as a prop to the provider component. By wrapping our app in the provider component, we make our Redux store available globally to every component in our app, and each component is made aware of the Redux state with the connect function. We'll see next how to set up the React-Redux container, but for now we're done setting up Redux. Now in this section, we'll set up our React-Redux container. We will cover hooking up a React component to Redux with the map state to props and map dispatch to props functions. We will also cover action creators. And you'll notice I repeat myself a little in this section, and this is because it will help in the continuity of the explanation. and it will make the explanation self-contained. So if it seems like I'm repeating myself, just bear with me. In React, components that are aware of the app state are referred to as containers. This is also true of React Redux. Only class-based React components will be aware of the Redux state. Functional components will not. In this section, we'll set up a simple container to test our Redux state. We can use the same container that we use for a React project, but let's start fresh and delete all the code in our container except for an empty div. At the top of our container file, we'll import our dependencies and both the actions and action types from our actions directory. Next, we can set up 3 buttons to see if our Redux store is working. Each button will describe its intended function and purpose, and each button will test a different part of our Redux store to make sure it's working properly. At the bottom of our container file, we'll set up 2 functions, map state to props and map dispatch to props. The map state to props takes the state parameter, and map dispatch to props takes the dispatch parameter. And they're both reserved keywords, and we have to use both of them in their functions. And they can't be interchanged or substituted for other keywords. And both these function names are describing exactly what these functions do. And they're very important because they're basically what allows us to use the Redux state with React. And since we're using Redux and the React Redux library to manage state, we're no longer using the React set state function. In complex apps, you'd use both these functions and set state, but for now we'll just focus on the React Redux functions. Now we need a way to connect these 2 functions with React. We can do this with the connect function from React Redux. We can first import it at the top and then call it at the bottom of our file. And notice that our 2 state functions and the container are wrapped in different parentheses. This may look strange if you haven't seen it before, but this is correct syntax. And now let's leave our app for a little bit and go a little bit deeper in these 2 functions. To go a little deeper in our map state to props function, we're essentially returning an object which has a key property called stateProp with a value of state.stateProp. The key is user defined, and we could have made this anything. We could have called it state property, property1, or anything else. The value is not up to us though. To set the value, we have to use the state keyword. then dot, then the name of the reducer, and then dot name of the property that we set in the specific reducer, which in this app was state prop. To use this value in our render method, we do exactly what the function name says. We use this.props.stateProps since we map the state to props. So we therefore use props instead of state to maintain immutability, which is one of the core tenets of React. And we pass this value in the onClick method of our first button, which is called getStateValue. This method is similar to the setState method that comes with React. The difference is that setState is only useful for the component it's used in, while this function will modify the state globally and allow us to use the state globally in our app. It's possible to use both this and the setState method together in the same component. This is seen in more complex apps, but not something we'll cover in this tutorial. And similar to the map state to props method, we're returning a key value pair. The name of the keys are up to us, and we can call them anything we want. The value of the keys is an arrow function that calls the dispatch method. The dispatch method then takes the value of an action as an argument and gets passed through the reducer. To use an action in the render method, we do exactly what the function name says and use props. We use this.props and the key name of the action we're dispatching. The actions are dispatched automatically and run through the reducer we set up. If the value of an action matches the case statement in the reducer, a new state is returned and the component re-renders automatically. You may be wondering exactly how the reducer is aware of what actions are being dispatched, and the answer is through the connect method. We import it at the top and we use it at the very last line of the component. So we can now go over the connect function. As its name describes, it essentially connects React with Redux, and it's part of the React-Redux library. And note that we're doing two separate parentheses calls. The first parentheses call is to the original function, and the second parentheses is calling the function inside the first function. And again, this is valid JavaScript code and the standard way to use the connect function. And below I have a table that describes the three scenarios you'll run into when using the connect function. So the first scenario would be a container that's both read and can dispatch actions. This is a standard container and you'll probably be using this one the most. And to use this one, you simply pass both the map state to props and map dispatch to props functions to the connect functions. And the order is important. You have to put the map state to props first and the map dispatch to props second. And the second scenario would be a read-only state container. This would be a container where you don't need to dispatch actions, but you only want to read the state. So to the connect function, you would only pass in the map state to props, and you do not have to set up the map dispatch to props function in this container. So the last scenario would be an actions-only container, and this would be a container where you only wanted to dispatch the actions, but you don't need to read the state. So how you would do this is you would first pass in null, then map dispatch to props as a second argument to the connect functions. And this is the only valid syntax. You can't just pass in map dispatch to props as the first argument to the connect function. So let's go back to our app and finish setting up our container. Let's first set up our state functions. And let's first set stateProp1 to state.stateProp1. And we went over in the last section how to do this, so please review it if you're confused about the syntax. In the map dispatch to props function, we can set up our actions with an arrow function, and then we have to pass in the action to the dispatch method. And now we can set up the Redux state inside of React. First, to display the state, we can use this.props.stateProp1. And for now, we can just console.log it. We don't have to render it to the screen. Next in our two buttons, we can dispatch actions with this.props and the name of the property we set in the map dispatch to props function. And let's just fix a few typos here. And that's it. We've successfully connected our React app with the Redux state. In the next section, we'll briefly go over the app and then we can test to see if it works. So let's review and provide a summary of what we think the app is supposed to do. Let's open our actions.js file and our reducer.js file so we can understand how our app is working together and we can better understand the Redux flow. To start, let's start in our actions.js file. We have two variables here called success and failure. The string version is what we created in the action types.js file, and then we imported them here. And these actions describe what will happen and will be dispatched from our React-Redux container. In our container, we have three buttons. The first button is just supposed to read the current state. Our state is only made up of one property called stateprop1, with only two possible values, so keeping track of it will be very simple. Our state is accessed with the map state to props function, and we can use the state in our render method by using this.props and the name of the key that we set. The next two buttons dispatch actions that will change the state with the map dispatch to props function, and we can dispatch actions by calling them in our render method with this.props and the name of the key that we set in that method. And when our actions are dispatched, they will run through the reducer. Now let's look at a reducer. We first begin by importing our action types. Next, we set the initial state, which is just a JavaScript object, and we could have made this anything we wanted. And after that, we initialize a reducer with the const keyword and set it up with an arrow function. We set our parameters and set the state to our initial state. And we created two case statements for each of our actions: the success action, which will make stateprop1 to true, and failure, which will make it back to false. And remember, in our container, the dispatch action 1 button will dispatch the success action, and dispatch action 2 button will dispatch the failure action. And now with the Redux flow summarized, we can test our app and accurately predict what will happen. So let's save everything and check our browser. Now for the moment of truth. Let's click our get state button, which should give us our default state, and it should print to false. And done, working as expected. Now to dispatch our action 1 button, which should change the state to true. Let's click on that button and click on the get state button again. And yes, it is working as expected. And finally, let's test our dispatch action 2 button. This should change the state back to false. And let's click it and check our state again. And perfect, it's working as intended. And in the next section, we'll set up our action creators. Now that we set up our actions, we can also easily set up our action creators. And action creators can seem intimidating at first, but if you remember, action creators are just functions that return actions. So literally, we'll just create a function that returns an action itself, which is itself just a JavaScript object. So essentially, an action creator is really just a function that returns a JavaScript object. So this is very standard, this is not too complicated. So let's go to our actions file, and we can use ES5 syntax and create an arrow function that returns an action, and set up the action creator as follows. And again, the name is up to us, and we can call the name of the function whatever we want. And again, we have to use the export keyword because we are going to use this function in other files. Note that we don't need to create a new action type. We're using the same action type that we've been using for regular actions. And let's also create an action creator for the failure action as well. And this is it. This is all we have to do to create an action creator. We don't even have to update the reducer since we're using the same action types. And next we can go in our container file and create 2 more buttons. Let's call these buttons dispatch action creator 1 and dispatch action creator 2. And down in our map dispatch to process method, let's add 2 more properties called action creator 1 and action creator 2. And same as plain actions, we can set the value of this property to an arrow function. Then in our dispatch method, instead of accessing the type with dot notation, we actually call the arrow function we set up in the actions file. We're essentially calling a function inside a function. And inside the onClick event in our 2 new buttons, we can use the same syntax to call the action creators. Let's save everything and test it out. So clicking on the dispatch action creator 1 button should make the state true, and clicking on the action creator 2 button should make it false again. And yes, it is working correctly. We've successfully set up our action creators. Now let's go over how to pass data into an action creator. Ideally, I would show you how to do this with an input field and show you how to save the user input to Redux. However, when I was creating the tutorial, I realized it was overly complex since we would have to set up 2 helper functions that extract the input with the synthetic event and then send that data to the Redux state. And I actually went over forms in React in the React module, and going over it again would take away from the action creator part too much. So to avoid that, I'll give you a simpler example using a button and a variable, and this will simulate getting data from the user input. And if you watch the React form tutorial and this tutorial, you will be able to do that on your own. And I'll also show you how to save the user input text to the Redux state in the project module. So if you can look in that module if you want to know how to do it. With that said, let's start in our action types file and create a new action type. And let's call this type user input. We can now go to our action files and create a new action creator. Let's also name this action creator to user input. And unlike our other 2 action creators, we will pass in a parameter to this action creator. And let's call this parameter text. In our return statement, we can also set a second property to action, which we'll call payload. And for now, we can just set our text parameter to the value of the payload. In a real-world app, you would ideally want to set up payload as a JavaScript object, but for now this is fine. And we also have to update our reducer to handle this new piece of state. Let's begin by setting a new property to our initial state. And let's call this property user text and set it to an empty string. Now let's create a new case statement to handle our new action type. Inside of our return statement, we can create a new copy of the state with a spread operator. Then we set our newly created state property of user text to action.payload. And where is this action.payload coming from? Let's retrace our steps. Note that our reducer takes two arguments, state and action. The action is the exact same action we defined in the actions file. If we look at our actions file, we see that the action we returned, which is a JS object, has a property of type and payload. And so this entire JavaScript object is available in the reducer, and the entire actions object is available in the actions parameter. Now with the Redux store setup completed, we can begin setting up our container. As mentioned, we will simulate a user input with a button and a string variable instead of having to set up an entire form. Let's create another button and call it dispatch action creator 3. And let's also create a string variable in our render method. And you can make this anything you want. I'll just make it text1. And then same as before, in the onClick event, we call action creator 3. And let's also define this in our map dispatch to props method. For now, let's just set it up as we did with our other action creators and leave the parameters empty. And we can begin to discuss how we would pass in our data. We first need to pass it in as a parameter to our action creators 3 call in our button. Simply pass in user text to the action dispatch. You can essentially imagine this string as an extracted value from a form or an input element. Next, we'll need to pass this parameter in our action creator 3 property in our map dispatch to props method. In the arrow function, we can just pass in text because we're basically saying that this function should have one argument, but the actual value of the parameter we have to pass in to our render method. For the same reason, we can just pass text to the dispatch action creator call. And this is it. Let's save everything and test our app. Let's first click on the dispatch action 3 button, and let's get the state from the get state button. We're getting false and our new user text property is not showing up at all. Let's look back at our code to see what's happening, and let's do this in the next section. In the last section, we were trying to get our user input property printed to the console, but we only saw false. Let's go back to our code and see why. Let's first look at our get state button. As you can see, we are only console.logging the first state prop, and this state prop is coming from our map state to props function. And as you can see, we only have the state prop defined here, and we want to access the user text property we defined in the reducer. And we can access this property the same way we access state prop 1. So simply create another user text property in the map state to props method and set it to state.user text. Now we can simply use this in our console.log statement, and we can also save everything to check if it works now. Let's first get the initial state, and yes, since it was an empty string, this is what we should be seeing in the console. And now let's click our dispatch action creator 3 button, and let's click our get state again, and yep, it is working. This is what we should be seeing here. Now let's do something else. Let's actually make this data display in our render method asynchronously. And let's think about how we would do this. I've alluded to this in one of the React lectures, and if you guessed Turner expression, that's correct. Then we set our condition, which will be this.props.userText. And this really means if this.props.userText has value. And again, we're getting this.props.userText from the map state to props function. After that, we need a question mark followed by some JSX. Let's render our text in a h1 tag. In our h1 tags, we simply pass in the value of this.props.userText. And also remember to wrap this.props.user text in curly brackets, otherwise you will render the string of this.props.user text. Our else statement can just be null, and this should work. Let's save and check. All we have to do is press the dispatch action creator 3 button, and our text should render to the screen. Let's click it, and yep, it works. Our virtual DOM changed, so our component was re-rendered automatically, so we didn't have to reload the page or anything like that. Another main topic we need to cover is using multiple reducers. Let's start in our reducer file and split it up. Let's take our newly created user input action and put it in its own reducer, and we can call it user reducer.js. Let's also delete the user input action from our original reducer and rename that reducer to reducer1. We can also delete the user text from the initial state. Finally, we need a way to combine these reducers. Create another file in your reducers folder called index.js. We will see in a second why we called this file index.js. In this file, import both the reducers and also import the combine reducers function from Redux. By convention, let's create a const and name it root reducer. This variable will contain the value of the combine reducer function. In this function, we pass in a user-defined property, and the value is the reducer we imported at the top. And remember the properties names, we will use them shortly. And finally, export the default root reducer at the bottom. Now go to the root index.js file in the source directory. Change the import statement by removing the reducer at the end and simply point to the reducers directory. Webpack will automatically add index.js if we leave it blank. There's only one more change we have to make in our container file. The actions can stay as they are. In our map state to props function, when we want to retrieve the state, we must now specify the reducer where the state is located, and the location will be the same as the user-defined property we set in the combine reducers function. So use stateprop equals state.reducer1.stateprop, and then user text equals state dot user reducer dot user text. We don't have to make any other changes to our container. The map dispatch to props can also stay as is. And let me just fix a typo right here. Let's now save everything and test our app. And yes, it's working as expected. And congrats on setting up your React-Redux app. This may seem simple, but this is really the cutting edge of technology you're working with, and very few people can proficiently or even understand this stuff. And if you can build this simple app, you're not that far off from building complex production apps with React and Redux. Good work, and keep going. So here's a chart for updating and reading the state in these 3 different libraries. Just refer back to this diagram if you're ever confused. We can now begin setting up our router in our app. Let's go over a high-level overview of routing in a single-page app, since it's very different than routing in a traditional web app. Routing in a traditional web app is done by requesting a new page from the server with every route change. This is not the case in single-page apps like React. As the name suggests, there's only one HTML page. This means that on a route change, a new page is not requested from the server. Instead, on a route change, a different UI is displayed on the page without reloading the browser. Each route is associated with a component. This is done through React's virtual DOM. It's possible to navigate the entire website without ever reloading the page. SPA routing results in a much faster performance app. This is the main advantage of using React and other single-page apps. Over time, the performance differences will be more significant and more websites will transition to single-page apps. Let's start coding by installing the library we'll use to help us with routing called the React Router. To save time, I've already done this. We will create a very simple app to just get a basic understanding of how to use React Router. We will just create 3 functional components that display some text. Instead of restarting, we can just use our app from the last section. Let's go to our functional directory and create 2 new files called component2 and component3. Let's save some time and copy and paste our code from our other functional component. Let's also delete all the code so these functional components only display the name of their component. We will set up routes in a file called routes.js, and this will be a React container. All the routing logic will be contained in this file. We first have to import all our components into this file. Next, let's import the two components that we'll use for routing from React Router. The first is router, the router component, and then the next is the route component. The router component is the parent component that will wrap all our declared routes, and the route component will hold the logic for associating each component with one route. And let's begin with an empty div and a React class. To declare routes, we need to make a parent component and then declare each route with the route component. We then have to make sure each route is declared inside the router component. Each route component takes two props, a path property and a component property. The path is the route that will be associated with a certain component, and the component property will be the entire component that we imported at the top. Now let's give each component its own route. Let's also import and make our container one the home page. Also remember to add a slash before the path name, which I forgot to do. For our simple app, this is all we need right now. However, this only holds the logic for routing. We didn't set up a way to access these routes yet. We will see how to do this in the next section. To actually set up the links, let's create a header component. We can create this header as a container since we'll be adding state to it in the next section. To actually add links to our app, we need the link component from React Router. Import this from the React Router DOM library instead of just the React Router library. React Router DOM is just a dependency of React Router, and it's installed automatically with React Router. The link component takes one prop called to. This is a string that takes in the same route as we set up in the routes.js file. So let's create a link for each of our routes that we set up. There's also an alternate syntax to set this up. Instead of a string, the to prop can also be an object, and the link to object can also have other optional properties such as path name, search, hash, and state. So to break each of these down, the path name property is just a string that matches the route. This is the default property when the toProp is specified. The search property is a optional property, and it's the search queries that you passed into the URL. You would see this if you set up a backend API and the user maybe submitted a form. Then we have the hash property. This is used in the same way hashes are used in vanilla HTML. So you can essentially use hashes to go to a specific part of the web page instead of defaulting to the top of the page. And then next we have the state property. This is itself a JavaScript object, and you can pass in whatever data you want. And note, this is different from the React and Redux state and does not affect those states at all. So after this, we now need to import this header to our routes.js file. So we want the header to be visible on each component. To do this, we can place our header inside of our router component without declaring a route for it. We have to place it inside the router component, otherwise React Router will give us a warning of links must be placed inside the router component. So this might be a little bit confusing, so how does this work? So I gave a brief overview of routing in a single page app in the beginning of this module, but I'll try to describe it a little bit further. So imagine the code inside the router tags as an if-else statement. So if a certain path, then a certain component. Instead of the component, imagine all the code of the component as a code block. So if a certain route, then display all the code for that component. And only one of the routes can be true at a time, so the other ones can't be rendered. And we're placing our header outside this supposed if-else statement by not declaring a route for it. So therefore it's always displayed. So that's one way to think about it that helped me to understand it more, and we'll continue setting up our routes in the next section. One more thing we have to do is set up a history object. So since the browser doesn't reload in a single page app, we need to set up the browser history manually. If we didn't do this, when the user clicked on the back button, they would be redirected to outside the website and to the page they were on before they visited our website, regardless of where they were. Luckily, setting up the history is very easy with the history library. Just install this library, and to save time I've already done this, but after that we can set up the history object. To do so, we'll need a new category since this is neither a functional component, container, or part of Redux. This can be best described as a utility file. So let's create a new directory called utils. Inside utils, let's create history.js. Let's first import create history from the history library, and then we can set it up with just one line of code. And then let's export default create history. Let's import this to our routes.js file. We have to set history as a prop to the router component. We also have to wrap everything in a div because the router object can only have one child component. Let's also change the path of container1 to just a slash. And finally, we have to export our routes class. Finally, we need to make our app.js class wrap our routes class. We first import routes and then just declare it in the JSX. We can also delete container1 in our JSX. Let's save everything and check. And yes, it does seem to be working. If we click on the links, the corresponding component is rendered. There are a couple of problems you'll notice instantly. First, all the links are bunched together and it looks kind of bad. Second, no matter what path we are on, the container is always displayed, but it should be only displayed for the home route, which is just a slash. Let's try to address these problems in the next section. To keep this tutorial concise, I'll do the bare minimum styling and layout. In the header component, add padding properties to the link style prop. If we save, we do see we do have a cleaner look in the header. Now let's work on our other problem. Let's also add a link for the default home path. So for some reason we're getting both container1 and the component when we enter a route. We only want to display the component that's associated with the route. How we have a router set up currently is that both these paths are matching. So this means that slash will always be rendered because all routes have a default slash route. Let's modify our code a bit to show this. Let's first not have a default path. Change it to /home. If you save and check the browser, it will no longer be displayed. And only the component associated with the corresponding link is rendered. So let's try this. Let's add /home path in front of all of our routes for our components. What do you predict will happen? Let's save and find out. Just enter the routes manually in the URL. If we go to /home, we see that our container is rendered. So far so good. How about /home/component1? And we see again that both our component1 and our container1 and our component1 are rendered. And why? Because both the paths are matching, since technically /home and /component1 at least contain /home. Both /home and /home/component1 are valid paths of both the component1 and the container1. Therefore, both the components are rendered. So how do we fix this? We will go over this in the next section. So in this section, we'll fix our problem from the last section. To start, let's first import the switch component from React Router. Wrap all your routes with the switch component. Switch basically tells the React Router to render only the first component that matches the path. And the order is important. If we put /home/component1 before /home/component1 would be rendered. Next, let's delete the /home from the paths. Finally, we need to pass the exact keyword to the home route. Let's save everything and test our app. And yes, it is working. We're only seeing the components that we want. Let's also look at another syntax for rendering components. Instead of the component prop, we can also pass in the render prop to a route instead. Let's change our prop from component to render. Inside the render prop, set curly brackets and declare an arrow function. And then in the code block, simply write the component as a JSX element. Using the render prop and the arrow function, you can also pass in JSX. Let's write div component1 div, and again, this is also valid syntax. Another thing we can do is access the default props given by the React Router library. To do this, simply enter in props for the argument in the arrow function and then pass it in with destructuring by setting 3 dots before props. In our component one, let's also console.log the entire props object. If we save and look at our console, we see the entire JavaScript object. And again, this is not something we set up, but a given feature of React Router. So we get a lot of default properties and data with the React Router. And we'll go over this deeper in the Auth0 module. In this section, we'll go over dynamically routing components. So far, we've seen how to render absolute paths by hard-coding them for every link. This, however, is something you would never do in production. Imagine if you had a React blog and you had to hard-code every link for a blog post. That would be insane. Let's now discuss dynamic rendering. Instead of component 1, 2, and 3, let's just have one functional component and render each component dynamically. Let's first delete our component 2 and 3 files from our directory and also delete the import and route statements. Let's go to the header and dynamically render each link in the header. Let's first initialize our state and then set a nums property. Next, we can set the value to an array of objects with an ID property. This will simulate maybe getting an array of posts from an API and then accessing each ID property from each post. Next, let's delete our links except for one. To dynamically render the links, we would use a map function on the nums property of state. Let's just cut and paste the link into the body of the map function and also pass in a parameter called num. Right now we're using an absolute path. We will now set up this as a relative path, and we can do this with string concatenation. Since we're rendering an array of data, we must also specify the key property to the link component. Simply enter key equals num.id. Now let's go to our routes file and dynamically set this up. Go to /component path and add :id. And this allows the path to be dynamic. And this is it for our routes file. We can also leave the prop as is. Back in our header, we can also render each link dynamically. Also, we can add a / after component in the header. But we're not done setting up dynamic routing yet. We also have to code for the component because every route just takes us to component 1. So let's go to our component 1 file. If we remember from the last section, we had some given props from React Router. There was a params property that contains our ID. We can simply access this in our code to dynamically render the component. Instead of hard coding the number of the component, we can do component, curly brackets, and then props.match.params.id. Now we're done, so let's save everything and check. And yes, we're getting the exact same functionality as before, but we're now doing it dynamically, and we can scale this as much as we want. There are a little more advanced techniques of routing we still have to cover, but those techniques are best demonstrated after learning authentication. So there are a few more routing related concepts that I have included in the Auth0 module. In this module, we'll go over authentication with the React and Redux. I will use Auth0 as an auth provider to build this app. However, the concepts and techniques you learn here can be directly translated to most other token-based authentication systems. Let's go over this diagram that shows the Auth0 flow. The Auth0 authentication flow has several steps. First, the user will click on a login button that is on our React app. Clicking on this button will actually redirect the user away from our app. The user will be redirected to a page hosted on the Auth0 servers. The user can either log in or sign up on this page. Once the user does this, the credentials are sent directly to Auth0. And this is very secure and allows us to not worry about hashing or storing our passwords. If the user's credentials are valid, Auth0 sends a JWT token to the user's browser, and we use our React app to save this token to local storage. We then use our React app to check if a JWT is saved in the local browser storage. If yes, then we update the user authentication state in Redux, and that's essentially how authentication works. In this section, I jump around a lot from component to component while building out the authentication system. I do this to break down in detail how everything works. This tutorial would not make sense if I just build out the entire component and then moved on to the next one. So I will partially build a component, jump to another one, and then partially build that one, and then jump back to the original one. Please take note of this because it might become difficult to follow along. So the first thing we have to do is sign up for Auth0. I've included a written tutorial in the next section on how to do that. After signing up, you'll be redirected to the dashboard. Auth0 gives you a lot of functionality out of the box. Applications will be the tab you will use most often. This sets up credentials and hooks up your app to Auth0. Other tabs you might find interesting will be users and the host page. Users allow you to see what user has logged in and when. Hosted page allows you to style the default page that a user is redirected to when they want to use Auth0 to sign in. I will now demonstrate how to set up Auth0 with a React app. Go to the Applications tab and click on Create App and select Single Page App. Name the app whatever you wish. After that, click on the Settings tab. Here we have all the important info about the Auth0 app we have just created. The two main things we'll need for our React-Redux app will be the domain name and client ID. A common question I often hear is, how do I make the client ID hidden and not accessible to our client-side users? And the answer is there's no reason to make the client ID hidden. The client ID is a public key and it's not meant to be a secret. The client secret, however, must be kept hidden. However, we don't have to deal with this because the client secret is only used for server-side authentication. For our purposes, we will use a client-side authentication. Let's finish setting up our Auth0 app. We only need to make a couple of changes to this app. In the allowed callback URL box, enter http://localhost/callback. And then underneath, just enter the localhost 3000 in allowed web origins. And remember, it's not HTTPS. If you're an advanced student and you have your React app running on another port, just substitute that port here. Otherwise, the default port for React app is localhost 3000. And remember the slash callback, and also do not add anything after the callback. After this, we can just scroll down to save the changes. And this is all we need to do on the Auth0 side to set up our app. Now let's go to our text editor and set up the React app. Now back to our React app. There's no point in restarting our app from scratch. Let's simply use the code we've been working with. First, we need to install the Auth0 SDK. Specifically, we'll be using the JavaScript SDK. Run npm install auth0/js. As always, so you don't have to look at a loading screen, I've already done this. And next, we'll set up the Auth0 as a utility file. So in the utils directory, create a file called auth.js. In the file, import the entire Auth0 object from auth0/-js. We will set up Auth0 as a JavaScript class and write all our business logic for authentication in this one class. The very first thing we need to do is create a auth property and assign it to the value of auth0.webauth. This one function will initialize our Auth0 app and connect it to the app we've created on the Auth0 website. We will pass in a JavaScript object to this function that will hold our Auth0 credentials. Our first two properties will be domain and client ID. The value of these will be strings of the same exact value as the properties in the Auth0 app on the website. We can simply go to the Auth0 website and copy and paste these credentials. Next is the callback URI, which is localhost 3000/callback for React apps. Next is the response type. This will be set to token space ID token. We'll need both of these for authentication, and we'll see how to use these shortly. Next is scope. Set scope to OpenID space profile space email. This will give us the full user profile info, which we can dynamically display. And we will see this more when we set up the user profile component. Now we're done initializing our Auth0 SDK, and we can write our first authentication function. Let's start with the basics and create a login function. Luckily, this is very easy to do with Auth0. We can simply call the auth property that holds the value of our initialized auth0.webauth function, and then on that function we call another function called .authorize. And remember from the Auth0 diagram that we're not actually handling any authentication, such as storing usernames and passwords. All of this is done on the Auth0 servers. The only thing the .authorize function does is redirect the user to the login page that's hosted on the Auth0 servers. Therefore, we have absolutely nothing to do with handling the username and password at all. Let's wrap this function call in an arrow function called login. And just to fix a small typo, let's change our import statement to Auth0. This is actually enough code to begin testing our app. Let's import this class to our container1 file like so. Next, let's create a const of auth outside the React container and set its value to a new auth object. left. After doing this, we can create a new button in our container called login and pass in auth.login in an arrow function to the onClick event. Let's save and check our app. And yes, it seems to be working. Clicking login brings the Auth0 page and allows the user to sign in. After signing up, we are asked permission to authorize Auth0 to sign us up next time. And we also get a response back from Auth0 in the URL. We'll look at this in the next section. Let's look at the response in detail. Access token, which holds the string of numbers and letters, we will store this in local state to authenticate users. Next we have expires in, which holds the milliseconds in which the token will expire. After that we have bearer and state, which is important but for Auth0, but something which we will not be using. After that we have the ID token. The ID token holds the payload data in JSON format of the user profile. Running a parsing function on this token will return a JSON, and we can actually see this. Let's copy the ID token. Next, we can go to jwt.io and copy the entire token into that encoded text box. Here you will get the decoded payload which holds all the data for the user. Pretty cool. In the next section, we'll continue building out our authentication system in our app. Let's now create a method to handle the access and ID token. Let's go in our auth.js file and underneath the login, create a method called handleAuth. We'll then use a given Auth0 function called parseHash. This method allows us to extract the results from the response that Auth0 gives us. This function also takes two parameters, error and auth response. Notice we're also calling another function inside the parseHash function. In the code block, let's write an if statement. Let's call the local storage function to save our tokens to the local browser storage. And the local storage is a given JavaScript function that is not part of Auth0 or React. It's actually part of the JavaScript window function. So windows.local storage is also valid code, but usually local storage is just called. And we need to set the access and ID token to the local storage like so. Local storage.setItem and then a string of ID token, and then the second argument is authResult.ID token. We also have to set the expires time. As you recall, the expiry time was only 7200 milliseconds, which is only 7.2 seconds. Let's increase the expiry time by 1000, which will give us an even 2 hours. So let's create a new variable called expiresAt and then multiply our expiresAt time by 1000. And also add those milliseconds to the current time, which we can get with date.getTime. And if you remember, date is part of vanilla JavaScript. It's not part of Auth0 or React. And then we need to run stringify on this because we will save it as a string. So set local storage set item string of expiresAt and then expiresAt. Then we just need an else statement for any errors. We can also now go over the logout method. The logout method is just the exact opposite of this. Simply remove all these properties from local state with the remove item method. Now we're done setting up this part of authentication, but we still need to implement some JSX. We also need to handle the /callback route because currently we don't have anything to handle this. Let's create a new functional component called callback, and this is a component the user is immediately redirected to after the Auth0 hosted page. In this component, just return a div with the text of callback. In a production app, you would show maybe a loading screen here, but for our purposes, we can just have a div. Now let's set up a simple route for this component as we've seen before in the React Router module. Now let's think about how we would get the data in the URL bar to the handle auth function. And remember that our React router has given us default props, and one of those properties was the URL. We saw that in the console.log statement in our component one in that module. Let's do that with our callback component. Let's console.log the props and log in to see what we get. Let's open the location property, and yes, there's our data located in the hash property. We can write a simple if statement to check if this property is present and then authenticate the user. Back in our routes file, let's create a new method outside of our routes component. Let's call it handle authentication and use an arrow function. Let's also pass in a parameter of props. Our access token data is located in the hash property in the location property, so we can use an if statement to check for this. Finally, inside the if statement, we'll need to call the function we created in our auth utility file. Let's also initialize a new auth object like we did in the container1 file. And we don't want to initialize two different auth objects, so let's just delete the one in container1. And we'll initialize that auth object and pass it down as a prop to container1. So let's change auth.login to this.props.auth.login. Let's go back to our routes.js file and pass in auth as a prop to container1. To do so, we have to change the component prop to render. Finally, we need a way to pass in the React router props to this handle authentication functions. And we can do this in the arrow function inside the render prop of the callback component, which we saw how to do in the React router module. Let's first wrap the code block in curly brackets and then add handle authentication. Remember to return the callback JSX now, since it's not in the component prop. Also remember to import auth if you haven't done so. And this is it. We can test to see if it's working. Let's save everything and go back to our browser. Let's log in. And so far so good. Remember that our handle auth method in our auth utility file was supposed to save the access token to local storage. And we can directly check this in our console.log. Type local storage.getItem and then access token in the console. If everything worked, we should see the access token. And yes, it works. Now that we have our auth data, we need a function to handle the authentication state. Let's make this function return true if the user is authenticated and false if not. We can easily do this by comparing our access token expiry time with the current time. So in our auth file, let's create a isAuthenticated function. In our isAuthenticated function, let's first get our expires at time and turn it into a string. Next, we can compare that expires time with the getTime function in JavaScript. We can now access the authentication state with this method, but we want the authentication state to be available globally in the app with the Redux state. We'll set up authentication with a auth-check utility file. Here's a small diagram to show you how it's going to work. And just to go over this diagram, so when a user is logged in, they're redirected to our callback component from the Auth0 hosted page. Then we automatically redirect them with the history.replace to our auth-check container where the Redux state is updated. And since our auth-check component is an empty div, the user does not see anything on the screen. And then finally, the user is redirected from the homepage to the homepage from the auth-check component with the updated Redux state. And then when a user logs out, the same thing happens. They're first redirected to the auth-check container where the Redux state is updated. Then they're redirected to the homepage from the auth-check component with the updated Redux state. Now back to our app. In the utilities directory, create a file called auth-check. This file will be set up as a React container. Here we'll make the Redux state aware of the auth state. Let's set this up for now as an empty React container. We also want this component to be called right after the user either logs in or logs out. To handle this, we can use the history library. We can import the history library into our auth component. Next, in the handle auth method, after all the code in the if statement, declare set timeout and then history.replace auth check with a time of 200 milliseconds. We can now set up our actions. In our actions file, we can create two new action types of login success and login failure. You can change login failure to logout success or remove login or something similar to that, but I like having the dichotomy of either success or failure and having the first word be login. But again, you can make this whatever you want if it makes it easier for you to understand. Now in our actions file, we can set up these actions as action creators. We call these simply login success and login failure. Now we have to update our reducers for these actions. We will actually create a new reducer called Auth0. We can set up our reducer as we've seen before in the Redux module and create a property called isAuthenticated. Now we have to use our Auth0 in the combine reducers function. Simply import it to the combine reducers file and set it up as we've seen before. In the next section, we'll continue building out our auth check component. Now we can further build out our empty auth check container. Let's first import our required files. Import the actions and also the history utility. Let's begin by setting up our React-Redux state. Let's set up the actions that we just created in the map and dispatch to props function. Now let's focus on the component did mount lifecycle method. We will implement most of the business logic here. Now we have to find a way to find the auth state of the user with the isAuthenticated method in our auth.js file. We could directly import the entire auth file here in our authcheck.js component, but we would have to initialize the auth object again, and we already initialized the auth object in the routes file. We can simply use that instance and pass it down as a prop as we did to container 1. Now let's go back to our routes file and then import our authcheck component. Next, let's declare a route for it called /authcheck. Remember, this is the same route that we declared in the auth component. We'll use the render property and also pass in the auth as a prop. Now we're done setting up the router for authcheck. Let's go back to our component did mount lifecycle method, where we also have to use the authentication action creators and history.replace. Make sure your actions are set up like so. In our render method, we can just return an empty div. And then let's just fix a small typo here. And let's save everything and test it out. Let's log in and see. Everything seems to be working so far. And if we check our Redux state in Redux DevTools, yes, isAuthenticated is true, so it is working. In the next section, we will go over allowing certain users to access certain routes. We'll also be going over getting the user profile and silent authentication. Let's now go over how to implement authenticated routes. To implement protected routes, we will make use of higher order components. Higher order components are simply functions that take in a component and return a new component. In this case, we'll take in the route component and return a protected route component. Doing this is not so hard. Let's create two new functional components. Let's create one called protected routes and one called unauth redirect. Simply pass in basic text to these components. Next, back in our routes.js file, let's create an arrow function called private route. This function will take two parameters, the component and auth. Auth will hold the authentication state. Next, in the code block, use the route component and pass in the render prop. We'll use props and then we'll use a conditional to check if the auth.isAuthenticated is equal to true. Then if true, we render the component, and if false, we redirect to the unauth redirect route, which we will set up. To redirect, we'll make use of the redirect component from React Router. Import it and set its path name to /redirect, which will automatically render the unauth redirect component. So now to set up the components in the router. Our unauth redirect can be set up as normal. Our private route, though, instead of using the route, we will use private route component instead. And since this returns a route component, this is fine to use here. And here we can also pass in our two props to the private component like so. Auth equals auth, which holds the entire auth object, and component equals private component, which is the component we want to render. And remember to also import these two components as well. Lastly, we need to set a link to the private component in our header, which we can set up normally. We don't have to set up a link to the unauth redirect since the component will render automatically. Now we can save everything and test our app. First, let's click on the private component while unauthenticated and see if we can access that route. As expected, clicking on the private route takes us to the redirect page. So let's sign in and see if we can access our authentication route. And yes, everything is working as expected. Clicking on the private route takes us to the private component after signing in. We have successfully set up authenticated routes, but there's still a couple of problems. We are already logged in, but we're still seeing the login button, and we do not have a way to log out yet. Let's fix these problems in the next section. Let's now fix our header so it shows the correct authentication button depending on whether the user is logged in or not. First, we need to convert the header into a React-Redux container, and this is something we've seen before. We just need the map state to props function. Once we have done this, we can make our header aware of the isAuthenticated property of state. Remember to import the connect function. Next, let's pass in auth as a prop to the header component in the routes file. After this, we can pass in the login and logout methods from auth to the two buttons and set them up with a ternary expression. The ternary expression will check if isAuthenticated is not true and display the login button. And you can also do the opposite and check if isAuthenticated is true and display the logout button. Either way is fine. Finally, let's delete the login button from container 1. And we can check if this is working. And yes, we should be seeing the login button, and let's log in. And yes, we are now seeing the logout button, and if we click it, it turns back into the login button. Perfect. In a modern app, you essentially have to have third-party OAuth logins. So that's what we'll do here. Let's set up Google and Facebook OAuth logins. And let's first start with Google. Log into the Google Developer Console or create a Google account if you don't have one. Here are the steps. To keep things concise, I'll quickly set this up without narrating it. If you're confused, just refer back to the slide, but it is very simple, and all the steps are here. Now let's go back to the Auth0 and click the try button. Let's copy the client ID and client secret generated by Google. And let's click try. And yes, it is working. Now for the Facebook setup. I will go through this in the same way I did for the Google OAuth. And again, all of these steps are here, and it is very simple. It's not too hard. Let's click try. And yes, it is working. Let's now set up the profile component. We can use the profile component to automatically set up the user's info without them having to set it up manually. But first, let's console.log the auth result in our handle auth function to see what the authentication data we're working with is. So let's go to our home page and click on login. Let's sign in with our Google login that we set up in the last section. And yes, it does seem to be working as expected. Let's open up our auth result object, and we can see that there's an ID token payload that contains all of the user info. So this is one way to extract the user's info. We can do it here in the handle auth method. So this is the easy way, and it definitely works, but in my opinion, it doesn't make the code very readable. It will be hard for another engineer to come in and understand how and where we're getting the user's profile data from. So let's get the user's profile another way. We can get the user's profile with a given Auth0 function. To set this up, we will use two functions. The first function we need will get the access token. Under our logout method, let's create a function called getAccessToken. This function will be an if-else statement that will check if an access token is in local storage. If yes, then we'll return the access token. If not, we can just return null. Next, let's create a getProfile function and start it off by declaring an access token variable. This variable will hold the result of the getAccessToken function. Then we declare an if statement that checks if the access token was returned. Next, we can use the given Auth0 function called this.auth.client.userinfo that extracts the user's data. Inside the parentheses, we can use an arrow function with two parameters, and profile. Then, if we have a profile, we can extract it. To extract it, we can just save it in an empty user profile object. Declare an empty user profile object near the top of the class, and inside the if statement, set this.userProfile to the profile object. Finally, we need to call our function. Let's call the getProfile function in our handleAuth method after setting the tokens in local storage and before our history.replace call. Great, so this is it for our auth.js file. We now need to use this in our auth check component. Since this function is called automatically, the only thing we need to do in the auth check is to save the user profile object to the Redux state with an action creator. So before we can use it in our auth check component, let's quickly set up the action creator to use this. We can do this in the next section. In this section, we'll set up our actions. As always, let's start in our action types file and declare two action types for adding and removing the user profile. Next, in our actions file, let's create two new action creators. The first one will be add profile. Remember to pass in a profile parameter here and also pass it to a payload property. The remove profile action can be set up as normal. Now we will set up the reducers for these actions in the auth reducer. Create a profile property and set it to null in the initial state. Then we can set up our case statements. Remember, the profile property will be set to action.payload in add profile and null in the remove profile. After this, we can set up our auth check component, which we will do in the next section. Now to set up the action dispatch in the auth check. We will not need to use a user profile from state in this component, so we just need to set up the action dispatch. So let's create two properties in the map dispatch, two props called add profile and remove profile. Remember to pass in a profile argument to add profile. We will call these actions in the component didMount method under the login success action before the history replace call. In the this.props.addProfile action creator, pass in this.props.auth.userProfile. Remember, the get profile is called automatically, so the user data should be saved to the user profile object automatically. Also remember that this.props.addProfile is referring to our React-Redux action creators, and this.props.auth.userProfile is referring to our regular React props. And in the else statement under login failure, we can call our remove profile action creator. Let's go to our auth file and increase the milliseconds to 2000, since I found 200 was too fast and the profile did not save to Redux. Instead of setting up our profile component, let's just test to see if it works by console.logging the user profile in our container1. Let's go to container1, and in the map dispatch to props method, let's create a property called user profile and set it to the profile property of the Redux state. Let's console.log it in our get state button. And let's save everything and test it out. First, let's click get state and we should see null. Good, that is our initial state. Next, let's log in. And if we click the get state button, we should see the profile data to our console. And yes, this is what we see. Let's just make sure and check our Redux dev tools to see if it's correct. And yes, it is working. So let's now create a component to dynamically render this data. In this section, we will dynamically render the user profile that we saved to the Redux store in the last section. Let's begin by creating a container that will house our profile data. And so we will need to do this in the containers directory. And of course, we will set this up as a React Redux container. As always, let's begin by setting up a React container with an empty div. We only need the map state to props function here. Now let's create a function to display the profile. Remember, we have to specify which property we want to display. We can't pass in the whole profile object. I will choose these 5 properties, but you can choose any properties that we saw in the console.log statement. Next, in the render method, we can use this function. We can just use this function and pass the profile in as a prop. This may look like a weird syntax, but it is totally valid. And we just now need to set up this component in our routes. Let's set this up as a private route, since unauthenticated users shouldn't be able to access the profile page. Let's also create a link to the profile in the header for easy access. Let's just fix a small typo here back in the profile file. Now let's save and check our app. Let's sign in. And yes, it does seem to be working. Now to access our profile page. And yes, all our info is here. This pattern can also be used to display the user profile data from Auth0 and also Facebook. We have one problem in our app. When the user reloads the browser, all our state is gone. Our tokens, however, are still saved in local storage. Instead of having the user sign in again, we can do what's called a silent authentication. If expire time is valid, we can update our Redux state in the background. So let's log in. And let's reload the browser and see an example of this. And yes, if we check the Redux dev tools, we are getting is authenticated to false. If we go to the console.log and see the expire time and the access token, they are still there in the browser. So clearly the user should get automatically authenticated if for whatever reason they reloaded the page. Let's now create a silent authentication method with React and Redux. Doing this will be easy. We can simply copy the code from the auth check component and paste it to our routes component in the routes component didMount lifecycle method. Since routes is a root component, the component didMount method will be called every time a new component renders. So let's just copy our code from the auth check component and paste it here. We can also delete the history.replace call since this is a silent authentication and the user should be unaware of it and not be redirected. We also have to turn routes into a React Redux container, so let's do this now. Now that's it. We can change this.props to just auth. Since we declared auth in this component, we're no longer using it as a prop. The other this.props actions have to stay as is since they're being used by the map dispatch to props function. To check our app, let's also add the isAuthenticated property to our getState button. Let's save and test our app. So let's log in. And so far so good. Let's now reload the browser. And if we're still logged in, we should be seeing the true in the console. So let's click the getState method, the getState button. And yes, it is returning true. Let's check our Redux dev tools, and we immediately see the profile is now an empty object. This is because Redux takes some time to update the state, and we're dispatching our actions too quickly. So there's an easy fix for this. Let's go back to our app and add 2 lines of code. So we first have to call the getProfile method from auth. And then to slow down our action dispatch, we can just wrap it in a set timeout function for, let's say, 2000 milliseconds. So let's save and test. And yes, there is our profile. And just to really make sure, let's go back to our routes file and remove the component didMount method. Let's save and try again. And yes, as predicted, it's not working. So we can be completely sure that our app is functioning as intended. So in this section, I'll cover why I didn't go over Redux Thunk. Basically, any functionality offered by Redux Thunk can be accomplished without Redux Thunk. Redux Thunk is mainly syntax sugar, meaning it makes code slightly easier to read. But in my opinion, the difference is so small, it's not even worth the time to learn it for such a slight advantage. So below I've included a Stack Overflow link that goes over this. If you see the example, the difference between using Redux Thunk and not using it is literally 2 words. So for that reason, I did not think it was worth going over. So let's first discuss hooks. What are hooks? Hooks are basically referring to the ability to hook class functionality to a functional component. And it's mainly to allow functional components to read and update state. And this is completely new and something we haven't seen in previous versions of React. And not having to use classes makes both development easier and it improves performance. And I don't think classes or Redux is going to go away anytime soon, but in the future you will see more and more people migrate to React hooks. So now we can discuss the 2 rules of using hooks. So the first rule is that you cannot have nested hooks calls. So the hook has to be the top level function that's called. So you cannot put a use effect hook inside of a function. You have to put the function inside of the use of the hook, the use effect hook. And the second one is you cannot call hooks outside of the function. And I think this one's pretty self-explanatory. I'm not gonna insult your intelligence by writing an example. So here's a chart that gives a basic overview of the 4 main hooks. There are 10 total hooks, but these are the 4 main ones that you'll probably use the most. So obviously I'll go into more detail about each of these hooks, but let's just start with the basic overview. So first we have the useState hook, and this is similar to the setState function in the previous version of React. And this hook allows us to read and update state in a functional component. And again, like I mentioned, I'll go over the exact syntax and how it works in the next section. So next we have the useEffect hook, and this is similar to the component didMount lifecycle method in the previous version of React. And you'll basically use this when you want to call a function automatically when the component renders. After that, we have the useContext, and this is similar to React-Redux, and it allows us to have a global state through the React Context API, which is a little bit different than hooks. Next, we have the useReducer hook, and this is also similar to React-Redux, and it allows us to update the local component state through Redux actions and reducers. And just to note, it does not by itself globally update the state. So just because you use reducer does not mean you're updating the state globally. It's only still in the local component state. The state is updated unless you use it with context, which we'll see how to do. So let's now discuss the first hook, which is useState. As mentioned in the last slide, useState is essentially the equivalent of setState, but it also initializes the state as well. In React classes, you initialize the state in the constructor function. Since functional components do not have a constructor property, you both change the state and initialize the state in one function, which is useState. And useState takes one parameter called the initial state, and this is basically the default value that you want to start off with. And the useState function returns an array of 2 elements. It returns the state value as the first element and setState function as the second element. And on the right hand side, I've shown you how it looks like without array destructuring. And without array destructuring, I think it makes it a little bit easier to see what's going on. And both the value and set value are variable names that are user defined, and we can make them anything we want. To actually update the state, you use the function name, which is the second argument in the array destructuring, and you do not use the useState hook. And again, since this is a function, we're not using the this keyword anywhere, and we don't have to use props.setValue. We just call the function directly. And instead of using props.value, we also just use value just as is. And again, we don't need to use the state keyword anywhere either. So on the right hand side, I've also included syntax on how to work with multiple state properties. If you want another state property, you have to use the useState hook again. So using the useState hook again gives you a new value2 property and another setValue2 function. So essentially how you want to think about it is when you're using React useState hook, each value of the state, each property of the state has its own setState function, and it is initialized with the useState hook. So to change value2, you can only do it through setValue, the setValue2 function. You cannot change value1 in any way using that function. And this is important to understand because this is very different from how you use the setState function in React class components. So you just use useState once at the beginning of the file, which initializes one property of state and its own setState function. You then use that initialized function to change the state, and you don't use the useState hook to change the state after that. And again, this is important to understand because this is very different than using the setState function in class components. To read the state, you just pass in the variable name directly in curly brackets to the render method. And again, you don't have to use the state keyword or the props keyword. And similar to React classes, the component re-renders automatically when the state changes. So next we have the useEffect hook, and this is comparable to the component didMount lifecycle method in React classes. So there are three main ways you can use this hook. The first one is not passing in any second argument to the useEffect hook. And doing this will make it be called every time a component renders. The second one is you can pass in an empty array as a second argument to the useEffect. Doing this will make it so useEffect is only called when the component first mounts, and this is the exact same functionality as component didMount. The last way you can use it is you can pass in a value in the array to the useEffect hook. Doing this will make it so useEffect is called when that value changes. So again, in my last slide I did mention we don't use a state keyword, and this is true as well. I just use state.value to convey that you can pass in a value of state here, and we'll see in more detail how this works in code, but for now, this should give you a good idea of how it works. Now we have the useReducer hook, and this hook essentially allows you to change the state through reducers and actions. And similar to the useState hook, we set it up in a similar way with array destructuring, where the first argument is the state value and the second argument is a function that changes the state. Unlike the useState hook, however, in the useReducer hook, we have to pass in a reducer as the first argument and then an initial state as the second argument. And similar to useState, in the array destructuring, state and dispatch are both user-defined variable names, and we could have called them anything we wanted. Actions are dispatched literally in the same exact way as they are in Redux. You don't have to make changes to either the actions or the action creators at all. To read state, you use state.state property, and state is not a reserved keyword, it's just the first argument we defined in the useReducer hook in the array destructuring, so we could have called it anything we wanted. State property though is a reserved word. It's the same state property that we set in the reducer in the initial state. If you need a refresher on reducers and actions, see the Redux module. So before discussing the useContext hook, let's first discuss what context is. So context is separate from React hooks. useContext is a React hook, but context itself is not part of React hooks. And context is a way to pass down props from a parent component to a deeply nested child component. In regular React, props can only be passed to a direct child component of a parent component. A parent can't pass props to a child of a child component. And context is essentially what allows us to have a global state. So here's a diagram that shows how to read and update the state with context. So to read the state, you have to initialize all the state in app.js, the root parent component. Then each value can be passed in as a single property to the value prop of provider, which we will see in a second. Once that's done, any child component of app.js can access that state. Then any child component can access the value of that state by using dot notation on the property name that we provided in the value prop. Now we can go over updating state. So similar to reading state, the updating state is all done in app.js. So functions to change the state are all declared in app.js. Then the entire function is passed down as a prop to the child component. And it's passed in as a prop to the same value prop of the provider. Then to actually change the state in the child component calls the prop. Then when the child component calls the prop, it's passed up back to app.js where the state is changed. The state is not changed in the child component itself. So now that we understand context, let's go over the use context hook. The very first thing you need to do is actually create the context. And this is very easy to do with just one line of code. So you can go in a separate context.js file, and then in a variable called context, you run react.createContext, and you can supply it any initial value that you want. The initial value is not important because it will get overridden in the value of the provider, the value prop of the provider, which we'll see in a second. And then you can just export default at the bottom. After you create the context, you have to import it in the root app.js file. And you can use the syntax I provided right here. After importing it to the root app.js file, you have to wrap all your routes with the context provider, as you see here. Then the context provider takes a value prop, which can be a JavaScript object that contains many properties itself. And these properties are all user defined, and you can make them either a value or an arrow function. And this is why I mentioned in the last slide that setting up the initial value in the context is irrelevant, because they're all updated right here in the value prop. So if you want to set values or functions, you have to do them here in the app.js file. Setting up props in the context file does not do anything. So far, we've been going over how to set up the context, but now we can see how to use the use context React hook. So the first thing we have to do is we have to import the entire context into the child component that we want to use it in. After importing it, we can initialize it like you see below. So simply pass in the entire context object to the use context React hook and save the value in a context variable. Then that's all you need to do to access the global state. In your render method, you can read the state with the following syntax: context, which is the variable name you initialized, and then state prop1, which is a property we saw in the last slide that was applied to the value prop in the provider. And to set the state, you simply use the arrow function and then context.update state. And remember, update state was the property name that we supplied to the value prop in the last slide. And finally, you can update the state in app.js through either useReducer or useState. Either one is fine. We can now go over the migration guide from Redux to React hooks. And migrating is actually very easy. You have to make very minimal changes. Actions do not have to be changed at all. You can leave them completely as is. And reducers don't really need to be changed either. Instead of exporting the default reducer, simply export both the initial state and the reducer. So don't use export default at the bottom. Then after exporting both the reducer and the initial state, simply pass both of them into the use reducer hook. And export and import actions as normal. And there's no changing actions. They're dispatched as normal as well. And of course, I'll go over an example in code to show you exactly how it's done. So here I made a table comparing the 6 different ways to read and update state in React. If you're ever confused, just refer back to this table. So we'll now put together everything we learned and build a React hook app. To keep things concise, we'll build on top of an existing React-Redux app. And this is a very basic app. And we'll do this because this will allow you to see React hooks compared to React-Redux side by side. And a lot of current projects still use Redux, so it's important to understand both approaches. And we won't change the existing React-Redux code, but build React hooks separately from scratch and integrate them into our project. So we will now begin building out our app. The very first thing we need to do is use the correct version of React. To use React hooks, we have to use version 16.8 or higher. To get these versions, we have to go in the package.json file and manually add them. Running create React app does not give you the 16.8 version. After changing the version in package.json, save the file and delete your node modules folder. Then in the terminal, run npm install again. So the very first thing we'll do is convert our app class to a React hook. Doing so is very straightforward. Simply delete the class and extends component keyword. After that, we can just turn app into an arrow function. Next, we can just delete the render function and don't forget the closing bracket. And this is really it. We now have set up a React hook. Now let's create another directory called hooks where we will store all our other hooks. And in this hooks directory, let's create a file called hookscontainer1.js. And this will be the main hook we will be working with. And also, to save a little bit of time, we can just copy the code from app.js and paste it into our hooks container file. So let's just now import our hooks container one from ./hook/hookscontainer1. Let's also add a route for our hooks container, and we can call the route just hooks container. And finally, let's test our app. We can just manually add hooks container to the URL since we don't have a header link set up yet. And yes, it does seem to be working. We should be seeing React hooks, and this is what we see. In this section, we'll go over how to use the useState hook. The first thing we have to do is import useState, which we can do as following. After importing it, we can set it up as we saw in the slides, and we can use array destructuring. And remember, the first value of the array is the actual state value, and the second value is the setState function for that specific value. And we can initialize useState with a default value of 0. I'll also include how to set up useState without array destructuring as a comment. So let's just start off with a very basic example to see how useState works. We can create two functions that will either increment or decrement the initial value of 0. In our first increment value function, we can use setValue and then reference the state value and add 1. Remember from the slides, we don't have to use the this keyword or the state keyword. We reference the state and setState function directly. And we can do the same thing for the decrement value function as well. In our render method, we can create two buttons that will handle both these functions. And remember to pass in an arrow function to the onClick method of the button for each function. Let's now create another div and then pass in the text of local state. And in the curly brackets, we can display our actual state to the UI. And remember to also add the const keyword before each function, since again, this is not a class. Let's now go in the header file and create a link to our hooks container, which we didn't do in the last section. And we can just copy and paste the code to save some time. We can now save our file and go to our browser to see if it's working. And yep, it's working perfectly as expected. So this is basically how you would use the useState hook. In this section, we'll go over how to use the useEffect hook, and we will begin by importing it from React. Next, we can call the useEffect function under our useState call. And inside the parentheses, we can start off with an arrow function. Next, we can use a setTimeout function, and this would maybe simulate an API request to get some data from a database or server. And we'll use this useEffect hook with another property of state. And to add another property, of course, we need another useState function. So let's just, under our first useState function, let's just initialize a couple of values. We'll come back to this in 1 second. Inside of our setTimeout arrow function, we can call setUseEffectValue. And again, remember, this is just equivalent to this.setState. And we can pass in a value of useEffectWork. And we can use a 3000 millisecond timeout. And also notice in our setUseEffectValue call, we're not saying useEffectValue equals useEffectWork. We can just directly pass in the string. We don't need to reference the useEffectValue. In our render method, we can conditionally render useEffectValue. So if useEffectValue is true, we can just display that useEffectValue. If not, we can just display the text of no value. Next, we can just finish our second useState hook and just pass in an initial value of null. And you can also do an empty string if you like. And let's just go back to our render method and add a line break. And this line break just means to give a space between each HTML element if you weren't sure. And now we can test our app. And yes, it does seem to be working. In the slides, I also showed you that you can use the useEffect hook and call it when a value changes by passing in that value as an argument to the array. And we'll see how this works next. So let's go back to our editor and create a new function called changeUseEffectValue. And inside the arrow function, we'll set the useEffectValue to, let's just say, some string. Let's also create a button for it and pass in changeUseEffectValue to the onClick method. And finally, we can pass in state value to the array. And remember, state value is our first state property in the useEffect hook. So basically what this code is supposed to do when state value changes, which we can change with the increment and decrement buttons. And if state value changes, then the useEffect value will change to useEffectWork. And we have the changeUseEffectValue function to really make sure that it's working and that it's not just being called by setTimeout. So let's save and test our app. So let's go to hooks container. And yes, the setTimeout is working. This is what we should be saying. And yes, clicking our change useEffect button should change the string, should change it to some string. Now if we click on the increment local state button, it should change state value to 1. And because state value changed to 1, our some string should go back to useEffectWorked. So let's click and see. And yes, it is working as expected. Perfect. In this section, we will go over the useReducer hook. And after importing it, we can initialize it with array destructuring. And remember, state and dispatch are user defined, and we could have called them anything. And our useReducer hooks takes 2 arguments, a reducer and an initial state. So let's actually create a reducer to work with our useReducer hook. In the store directory, let's create a hooks state folder, and then we can create a hooksReducer.js file. And to save some time, we can just copy and paste our code from reducer1. Let's get rid of the export default call and export both the hooks reducer and the initial state as well. And here are the actions we will use. We don't need to change them at all. So let's import the reducer we just set up. And remember to import star as reducer since it's not export default anymore. Then we can pass in the reducer as the first argument to use reducer. And remember, the reducer.hooks reducer means the reducer that we set up in the import statement dot in the name of the reducer we set up in the hooks reducer file. And then we can set up the initial state in the same way. Next, we can import our actions the same way that we did our reducer. To handle our actions, let's create a arrow function called handle dispatch true. And then we can do dispatch and then in the parentheses actions.success. And again, the .success is an action creator that's coming from our actions.js file. And all it does is return the type of action types.success, which is just a string of success. And I'll also include two other dispatch methods on top of the actions.success call. And all these are three different ways to dispatch actions, and they're doing the same thing. They're returning a JavaScript object with a type property and a value of the string of success. And now we can create a handle dispatch false function, and this will dispatch the failure actions. And let's also create two new buttons to handle these functions. And let's pass in the functions to the onClick method in the same way we've been doing. And finally, in our render method, we can display some text depending on whether the property is true or false. So let's first start off with state dot. And remember, state is not a special keyword here. It's just the first argument in the useReducer call. And it was user defined and we could have made this anything. But since we're using useReducer, it's convention to just name it state in dispatch. Next, it would be state.stateProp1. And remember, stateProp1 is just a property in the initial state of our hooks reducer. And that's where we're getting it from our reducer. We don't have stateProp1 defined anywhere in this hooks container one. So let's finish off our ternary expression. So if stateProp1 is true, we can just display stateProp1 is true to the UI. And if false, we can just display stateProp1 is false. So let's save everything and check. And yes, we should be seeing stateProp1 is false because that was the initial value we set in our hooks reducer. And if we click the dispatch true button, it should change to stateProp1 is true. And yes, it is working. Perfect. So in the last section, we successfully set up the state in our React hook. However, we do have one problem. When our state works in the React component, but when we go to another component and then go back to our React hook does not save the state. This is because the state is reset when we navigate to another component and the state is not accessible globally. To fix this and have a sort of global state, we can implement React context. So here's a diagram to give a basic overview of how context works. And one of the most important things to understand about context is that all the state is initialized, contained, and updated in the root component. So on the left hand side, we have the first diagram which shows how to read the state. And this is a little bit different from what we've seen in Redux. So in context, basically the state is initialized in the root app.js component and then passed down as a prop to a child component. And since the app.js is the root component, all the other components are child components. And this is basically what allows us to have a sort of global state that can be read and updated in every component. And next on the right hand side, we have the diagram to update the state. Updating the state is done in a similar manner to reading the state, where props are passed down to the child component. And these props contain a arrow function usually. But unlike reading state, to update the state, the props are actually passed back up to the app.js, where the state is actually changed. The state is not changed in the child component. And again, this is important to understand, and just to repeat myself a little bit, both the reading and updating state are done in the app.js component. And again, props are passed down through the value prop of the provider. And again, we'll see how this works in code in a second. So let's go back to our app and create a context.js file in our utils directory. In this file, we will initialize our context object. And the first thing we'll do is import React. Next, let's declare a variable called context. And we can set this variable equal to the value of react.createContext. And inside the context parentheses, include curly brackets, and then set prop1 to the value of false. And finally, we can just export the context at the bottom. And this is it. This is all we had to do to initialize our context object. Next, let's go to our app.js file and then import this context object we just created. To actually use this context object, we have to go in our render method and then declare context.provider as a functional component, and make sure you're wrapping routes with the context.provider. Also initialize a value prop to the context provider as well. This value prop is what will hold all of our props that will be passed down to child components. Next, let's give our app.js some state with the useState hook. And let's call it state global and set state global. Even though we're initializing and declaring our state in app.js, we'll be able to read and update the state from any other component in our app. Next, let's just create two basic functions to increment and decrement the global states. So even though we're declaring these functions in app.js, we will actually pass them down as properties to the value prop. And by passing them down as properties, we will be able to access them in every component in our app. And this is what will allow us to globally update the state. And inside of our increment and decrement functions, we're using the useState hook normally, as we've seen before. So let's now go to our value prop and pass in the state value itself and both of the functions to change the state value as properties. So let's first start with value global state. And this key is user defined and we can make it anything we want. And let's set the value of this to state global. And this is the name of our state value that we used in the useState hook, and it's not user defined. And then let's create two new properties called add global value and dec global value, and we'll set both of these properties to an arrow function that calls our increment and decrement global state functions. Then in our child component, as we'll see in a little bit, we'll actually call these properties and not the function itself. So in a child component, we'll essentially call this property, which will call the increment and decrement global state functions in app.js. So let's go to our hooks container one and import the context object. And this is not the context provider we just set up in app.js, but this is the first context object we set up in context.js. And let's also import the useContext hook, which we will use in combination with this context object. So to connect the useContext React hook with the context, it's actually very simple. Simply declare a context variable and then just pass in context to the useContext hook. And this is really it. This is all we need to do to access and update the global state. And to access it, we do context dot and then the name of the property that we set in the value prop. So let's write some code to see what this looks like. Let's now go to our global state and add two new buttons. One to increment the global state and the second one to decrement the global state. In the onClick method of our buttons, we can call the props to change the state by using the syntax context dot and then remember the name of the property we set in the value prop and not the name of the function that we set in app.js. So in our onClick method, it will be context dot add global value. And now we can go and display our global state value. Under the local state, let's create a paragraph and pass in the text of global state : Then to actually display the global state value, we can, in curly brackets, use the syntax context.value global state. And remember, this is the property we set in the value prop of the provider in app.js. Now we can save everything and test our app. So we can go to our hooks container and then increment the global state. And just to really make sure, we can also increment the local state as well. After doing this, let's go back to the home component. And after coming back to the hooks container, as expected, we see local state went back to 0 and our global state is still as is. And this is perfect. This is the exact functionality we want. We want our global state to persist when we leave a certain component. So in the last section, we saw how to use the useState hook with the React context API. In this section, we will set up context with the useReducer hook. And this functionality will closely mimic Redux. Let's start off by creating a new property of state in our initial state in the hooks reducer. And let's just call it stateprop2 and initialize it to false. And instead of creating new actions for this one property, we can just add it to our already existing action types of success and failure. So just add it as a second property after stateprop1. So we're going to set up the useReducer hook in the exact same way that we did in hooks container 1. And to save some time, we can just copy and paste the code from that file. And in the import statements, remember to do // instead of // And then in our useReducer variable names, let's change the names to state context global and dispatch context global. And then we can create two functions to handle dispatching actions in the exact same way that we did in hooks container 1. And to save some time, we can just copy and paste the code from there. There's no advantage to writing these functions from scratch. And just so we can tell them apart, let's change the names to handle context dispatch true and handle context dispatch false. Now we can go to our value prop and then pass in these functions to the properties. And we'll do this in a similar way that we did with the useState hook. Let's first set the value of the state, and let's call this property reducer global state. And to access the value, it's a little bit different than what we saw in useState hook. We actually do state context global dot stateprop2. And remember, state context global is the value we set as the variable name in the useReducer hook, and stateprop2 is actually the value we set in the initial state in actually the hooks reducer file. So unlike the useState hook, you actually have to specify the specific property because state context global holds both stateprop1 and stateprop2. To pass the functions down as props, we can do it literally the same exact way as we saw in useState. Let's declare a property called dispatch context true and then pass in an arrow function that calls the handle context dispatch true function. And we can do the same thing for the dispatching the failure action as well. So we're actually now done setting up the app.js file, and we can go back to our hooks container to use these properties we just set. So as we've been doing so far, we can create two buttons that will change the state first. And also, we don't have to initialize the context because, as you see at the top of the file, we already have it initialized. So we can just continue using this same context variable. We don't have to initialize another one for the useReducer hook. And again, to call the functions to change the state, we just do context.dispatch context true, which is just the name of the property we set in the value prop. And in our render method, we can also display the stateprop1 and access the reducer global state the same exact way that we did the value global state. So just do context.reducer global state. And since it's a boolean, we can pass in a paragraph text saying stateprop2 is true or false. And I'll just quickly summarize what's happening here. So context.reducer global state is a property we user defined in the value prop in app.js. And this reducer global state property holds the value of state context global dot state prop2. And state context global is a variable we define that holds the value of the use reducer hook. And the use reducer hook can access the state prop2 value we set in the hooks reducer.js file. So hopefully that helps you better understand the flow and where everything is coming from and how it works together. And let's just quickly fix a typo here. It should be dispatch context global, not just dispatch. And let's check our hooks container1 file to see if we have any typos. And yes, it seems we're missing a closing p tag. And let's check the rest of our hooks container. And it seems to be fine, so let's save everything and check our browser. So let's go to our hooks container and then dispatch the context true action. And yes, state prop2 is now true. So let's go to the home component and go back to our hooks container to see if the state persists. And yes, even though we went to another component, our state prop2 is still true, which means it is working. So in this section, we will apply everything we've learned and create a form that uses all three ways of React hooks to update state. So let's start in our hooks directory and create a file called hooksform.js. And we can just initialize it as an empty div for now. We also need to declare a route for this, so let's go in our routes file and do this. And let's also create a link for it in our header. Now we can go back to our hooks form and begin setting it up. So at the top, we can import all our three main ways to update state with hooks, which is use state, use reducer, and use context. So we'll first start off with the use state hook, and we can set it up as we've seen before. And we can also initialize it with an empty string for now. And in our render method, we can create a form to work with this state. And let's also use a label of React use state and an ID of use state as well. And since this is a form, we also need a piece of state to handle the change input. And a more detailed explanation on why, you can see the form tutorial in the React module. And to keep things consistent, we can also change our original state variable names to value submit and set value submit. So we basically now have two pieces of state, one to handle the change and one to handle the submit of the form. Next, we can create two new functions to handle each of these pieces of state. Then we can pass in the respective set function call inside of each function. And don't forget the event keyword. And finally, just pass in a reference to each function inside the form. And again, this is all something we've seen before. If you want a detailed explanation of each part of this, just see the React Forms tutorial in the React module. And finally, we can just display our React use state values to the UI so we can see them both in real time. Finally, let's just add the event.preventDefault call in our submit function. And this is it for the use state hook. In the next section, we'll look at how to use the use reducer hook with the form. So in the last section, we saw how to set up state with React hooks and the use state hook. In this section, we'll see how to set up state with the use reducer hook. And let's also create two new actions to work with the use context hook. Let's go in our action types file and create a user input change and user input submit action type. Next, in our actions file, let's create two new action creators to handle these action types. Let's just copy and paste our code to make it easier for ourselves. And remember to pass in text as a parameter and then set a payload property to text. And next, we need to create a reducer to work with these actions. So in the hook state directory, we can create a new reducer. And again, to save time, we can just copy and paste the code from our original hooks reducer. In our initial state in this reducer, let's create two properties called user text change and user text submit. And let's change the name of the reducer to user reducer. And also let's pass in the action types that we set up in the last step. We are now done setting up the reducer and actions, and we can now import them into our hooks form. Next, we can pass in our user reducer to the use reducer hook in the same way we've seen before. And remember, it's a user reducer dot user reducer. Next, let's create two new functions that will handle dispatching actions and changing our state. So let's call them handle use reducer change and handle use reducer submit. And then we can pass in dispatch and then actions.user input change. And user input change accepts a parameter of text. So we can pass in event.target.value, which holds the value of the text that we want to save to the state. And remember, the submit reducer will take event.target.user-reducer.value. And again, remember, user input change is the name of our action creator. Next, in our render method, we will set up the form in the exact same way that we did with the use state hook. Simply copy and paste and then change everywhere it says use state to use reducer. And also remember to pass in the correct function references to onSubmit and onChange. And then let's also display the state for use reducer in the UI the same way we did with use state. And again, to save time, just copy and paste. And again, remember, these properties are coming from the initial state we set in the user reducer. Do user state.user text change and user text submit. And let's also change dispatch to user dispatch, since that is the variable name we set in our use reducer call. And let's just look through our files and see if there's any typos. And yes, action types.user input submit is spelled wrong, so let's just fix it really quick. And we also have a couple back in our hooks form. Let's add event.prevent default and also change set value change to set value submit. So this should be it. Let's save and test. As we type, we see, yes, it is working as expected. Submit does not follow change and it stays the way it should. Perfect. So in the last section, we successfully set up our hooks form with use reducer and use state. But as we know, that doesn't mean our state is available globally. So in this section, we'll set up our form with use context. So as we've seen before, let's start off in our app.js file. And let's import our user reducer we set up previously. And then let's use the use reducer hook in the same way we've seen before. And let's call the variable names state user and dispatch user. And then we can just pass in our user reducer and our initial state. And since we're going to be using the same actions, let's just copy and paste the code from our hooks form that we set up in the user reducer hook in the last section. And then let's just make the required changes to these two functions. Let's change the name to use context submit. And let's also do dispatch user. And we also need the event.persist function call. And this is really because context is a little bit strange, and since we're passing data up from a hooks form to the parent component, it doesn't always work perfectly. So you need this event.persist call to make it work without errors. So let's go in our value prop and then create a property to handle these functions. And let's name these properties use context change and use context submit. And then let's use state user, and remember this is coming from the user defined variable name we declared above. That holds the result of our use reducer hook call. And then for our second value, we can also use the state user keyword and then .user text submit, because remember the use reducer hook contains the entire initial state. So we don't need to use another use reducer hook to access another property of our state in that reducer. And next, as we've seen before, let's just create two new properties to hold the arrow function for each of our dispatch action functions. And since the name is a little long, we can just copy and paste it here. Now let's go back to our hooks form and set up the context. So the very first thing we need to do is import the entire context object from utils/context. And then as we've seen before, we can just supply that context to the useContext hook and save the result in a variable called context. And then the same exact thing we've been doing, let's create another form to use with this useContext hook. And again, just change all the useReducer text to useContext. And one thing I always forget to do, let's change the submit function in our app.js file. So it should be event.target.useContext.value, since this is the ID we're going to set in the input. And remember, when we're passing in the reference to the function, in our onChange and onSubmit events, it's going to be useContextHandleChange and useContextHandleSubmit, which are the property names we set in the value prop in app.js. And following the same pattern as we've been doing so far, let's also display the state to the UI. So under the React useReducer UI display, we can just create another one for useContext. And then to display the UI, we use context.useContextSubmit. Since again, that's the name of the property we set in the value prop. We don't use stateUser.userInputText or anything like that. We have to use the property name in the value prop. And finally, we have to pass the event keyword to both of our error functions. So this is it. We can now test our app. So let's go to our browser. So yes, if we begin typing, we're getting the expected output on the screen. But to really test it, let's go back to the home component and go back to our hooks form. It should be saved even though we went to a different component. And perfect, it's working. So let's try something else. Let's try to display this state in another component actually. So we'll change the state from this component, but display it in our another one, in our hooks container. So let's go to our hooks container. And under the useEffectValue Turner expression, let's create another Turner expression. And again, we can just do context.userContextSubmit in the same way we did in the form. And we don't have to initialize another context variable since we already have it initialized here. And then if userContextSubmit is true, we can just display that text. And if not, we can just display no user text. So let's save and test our app. So in our hooks form, let's type in some random text and hit submit. Again, if we go to home and then go on the hooks container, yep, there it is, it's working. Our text is displayed that we submitted in the hooks form. So this is it. This is literally how you set up a global state with just React hooks. So by now you should be able to build upon everything you learned in this course and build up very complex apps. For example, authentication systems, in API requests. Everything I've taught you is basically all the building blocks you need to do those complex apps.